I'm going to study the Pixi-viewport and I'm gonna train touch typing. But I don't wanna put a lot of pressure right now because it's already late. So I just wanna do like a chill stream to study this. But I'm not gonna like put pressure on myself to solve the problem now. I think I'll do that tomorrow. Just solve the issue that I'm getting with viewports and the React Pixi. And I watched a lot of videos. I think it's a lot more clear in my mind right now. Maybe I'll explain how I think that React works right now. And I think I'm going to study this file here, and I might study the source code for React as well. I saw a video that a guy did. I forgot the name of the channel. It is a very good video. There's something, yeah, here. Then he shows on one of these files that you can see the code for the fiber and how it works. I think it's this one. It's just pretty interesting. But I think I'm gonna spend a lot of time studying the code that I have there for the other library because I think I don't have time right now to study. But maybe one day, like, it would be good to study the source code for React to understand, because obviously I understand the concepts now, but I don't understand the source code really well. I'm gonna put some music, and I think I'm gonna maybe open SkyDraw to try to explain the way that I think it works. Maybe I don't need SkyDraw, just talk about it. I think I'm gonna do some touch typing as well. I was thinking about getting the React documentation or some other documentation, something that I want to study, and putting here to type. So that way I would read and train typing at the same time. Damn, they changed the background. Nice. This is a drawing that I did when I was thinking about. I don't remember what I was watching, but I think I was watching the videos about the anatomy of the brain, and then I realized that, like, obviously I'm not sure about this, but it's just a thought that I had, which is that the right side of the brain is connected to the left part of the body, and the left side of the brain is connected to the right part, so it's like crossed like this. And then it made me realize that it's a very similar pattern from the way that the gravity works, I think. So the way that I think it works is like a vortex, or like a fractal spiral, like this. So this pattern here, which goes back to the top here, like from this point in the end, you would go back to here, and then it goes on forever. So I think that the brain mimics this symmetry of left and right, and this fractal pattern that shows up everywhere in nature. It's pretty interesting. But obviously it's not related to the thing. So I think that the way that it works is you have the real dome, then you have the virtual dome, and then between these two things here, you have the fiber. And the fiber is the thing that has the reconciler, which is the diffing algorithm. And the way that it works is pretty much like a manager to figure out what parts of the DOM need to be updated first. Because let's say, for example, you have input that users type in the email or password. This would be a high priority input because it needs to be fast, obviously. And some notification from an API or something like that, or some data, you would be low priority because it's not necessary for that thing to get updated right away. So the reason for having the fiber, which is the thing that connects both of them, which has the tree, is that it allows you to create this hierarchy of importance when scheduling things. And this is pretty much what building a custom renderer allows you to do, because the React itself only says things about the structure of the virtual DOM, I think, and the way that it connects with the real DOM, because the React is the structure of the syntax of the functional components that become like the objects that have functions. So each component is an object that contains the some properties, and then there is one property of a component that is the type of that has a $, which is a symbol, which and the reason why is to prevent cross-site scripting, or like a hack that exists. So it creates a unique hash for the thing, for the components. But yeah, so there is the key, then there's type, which I think that type maybe was type with $. Type of $, is the symbol, React symbol, and this is the thing that prevents the cross-site scripting. Then you have props and you have children, I think. So this is pretty much the way that React component works. It's just an object with these values, and then each value, the children can have other children, and then it creates a tree structure. But then React itself doesn't say anything about the way that this is updated. So the way that this virtual DOM is compared with the real DOM. That's the job of the reconciler, which is the fiber tree. So you can implement your own renderer, and then you can change or optimize things, I think, on the way that tasks are going to be prioritized. And I think that's what's happening here. But the way that they are doing things here are kind of weird, because they are not directly using this library here. Like, they are not importing this library here. So I don't understand really well how it works on this context and why they did it this way. So I assume that the error that I'm getting there is because they implement their own custom renderer here for the components on the Pixi-viewport, on the React Pixi library, and then Pixi-viewport assumes a normal renderer, and then there's something that happens when you're triggering the wheel event that makes like a disconnection between the two. So I went to study more like what is the logic here, how are they creating this custom renderer, and what is the difference between the main one, and then obviously why does that difference makes it so that when you trigger the wheel event on the Pixi-viewport, it messes up the state. It's a very difficult problem, I think. It might take me a lot of time to solve this, like even days, I think, because I don't know, like it could be, the difficult part is that it could be on a bunch of different places, let's say. So because I don't understand really well exactly where it's coming from, it's kind of hard to, because I might have to spend a bunch of time trying to understand this file here, and then spend a bunch of time trying to understand the source code for the React DOM version to understand what is the difference. And then after that, I still have to think about how does the function that is triggered by the event listener is messing up the state. I think I'm just gonna read this stuff until something catches my eye that might be related to the React fiber or the renderer. And then from there, because I need to find an entry point, let's say, where I can analyze the execution from that entry point. Like to understand how is this file creating the renderer? That's the thing. How does this file manages the updates that happens on the DOM when there's an inside component? And from the videos that I saw, I think that you can have two different components, because on the host configuration, which is the thing that you pass to the reconciler when you're going to create a custom renderer, you can pass a key value pair that says whether or not that renderer is the root one or not, let's say. So I assume like you can have several different renderers inside of one React application. And then, but the thing that is tricky is like how they are connected. But I think React is gonna create the tree, and then the only thing that changes is the functions that are being called when it's time to update the DOM, which is the job of the React fiber. And then depending on which component is going to be, then it's going to delegate that task to different renderers in the application. I think that's how it works. I didn't look into the documentation from React. I think I'm gonna do that now. Just see how they explain the fiber. And then there is two different elements here. That one is the begin work or something like that. I don't remember the name of the functions really well. I think it's begin work and work in progress. It's something like this. So it's pretty much two different phases. One phase is the rendering. One phase is the updating and the other is the rendering. So in the updating phase is just selecting, flagging what stuff is going to be updated and what's the importance, I think. And then on the rendering phase is just it updates everything and commits the changes to the real DOM, I think. And it's React fiber that does that. And this also has the reconciler. It's pretty much like this that it works. It's not that complicated, but like it's difficult to find information, I think, explaining the... What makes it complicated is the context of the application, I think. That's what it makes it difficult, and also understanding like the functions themselves that are implementing these things. Like on the concept level is not that hard, but to understand how the functions are doing it, it gets harder, I think. It's also because it's hard to find information. Or maybe it's because because I know that the React documentation is very good. But when it comes to videos, I think it's kind of hard. It's because it's one of those things where you don't know what you don't know. So, like for someone that is learning by themselves, it's hard to find videos because in the videos, like people don't talk about this kind of stuff in the videos that are related to other things. Like, so if you don't know like the keywords, it's hard to find. Let's see if there's anything about this here. Interesting. Pretty sure there is a dark mode for this. Maybe it's another site that I'm confusing. This one. I think I'm gonna read this with the text-to-speech. And I think it's gonna be a pain in the ass to solve the thing. Like, there's just too many places to think about where to start looking on how to solve. Also, like the other thing that I think is gonna be hard to find is information about the fundamentals of how event listeners are related to state in React. That's the other main thing that I want to search for. So like what happens, but I think from now, like from the logic that I have in my mind, I think I kind of understand where the event listener triggers a function, which is the callback function you pass there. And then based on the logic of the function, it's gonna change the state on certain components. And then based on the components that it changes the state, then React is gonna change the state of that component. But I think the fundamental thing that I have to search is how is the connection between the custom renderer and the other renderer, and how that changes the tree. I think that's the main thing. And that kind of thing is going to be hard to find information.
Unwatch stop ignoring watch 321 notifications participating and it mentions only receive notifications from this repository when participating or it mentioned. All activity notified of all notifications on this repository. Ignore never be notified. Custom select events you want to be notified of in addition to participating and it mentions. Get push notifications on iOS or Android. Custom select events you want to be notified of in addition to participating and it mentions. Issues, pull requests, releases, discussions are not enabled for this. React Fiber architecture. Introduction. React Fiber is an ongoing reimplementation of React's core algorithm. It is the culmination of over 2 years of research by the React team. The goal of React Fiber is to increase its suitability for areas like animation, layout, and gestures. Its headline feature is incremental rendering, the ability to split rendering work into chunks and spread it out over multiple frames. Other key features include the ability to pause, abort, or reuse work as new updates come in, the ability to assign priority to different types of updates, and new concurrency primitives. About this document, Fiber introduces several novel concepts that are difficult to grok solely by looking at code. This document began as a collection of notes I took as I followed along with Fiber's implementation in the React project. As it grew, I realized it may be a helpful resource for others, too. I'll attempt to use the plainest language possible, and to avoid jargon by explicitly defining key terms. I'll also link heavily to external resources when possible. Please note that I am not on the React team, and do not speak from any authority. This is not an official document. I have asked members of the React team to review it for accuracy. This is also a work in progress. Fiber is an ongoing project that will likely undergo significant refactors before it's completed. Also ongoing are my attempts at documenting its design here. Improvements and suggestions are highly welcome. My goal is that after reading this document, you will understand Fiber well enough to follow along as it's implemented, and eventually even be able to contribute back to React. Prerequisites. I strongly suggest that you are familiar with the following resources before continuing. React components, elements, and instances. Component is often an overloaded term. A firm grasp of these terms is crucial. Reconciliation. A high-level description of React's reconciliation algorithm. React basic theoretical concepts. A description of the
I think I'm gonna ask ChatGPT as well, because I couldn't find. I think I already know what it is, but I'm still uncertain about it, which is a primitive. So what is a primitive in the context of React? Because I think a primitive is any element that is like kind of fundamental to the language. So like a primitive in JavaScript is any value. So an object is not a primitive because it creates a reference to the object, but the other values like strings, I think, or numbers, things like that are primitives. And in HTML it would be like an element like a paragraph tag or a h1 or a div, like things like that. But in the context of React, I don't understand really well, because like there are elements that are created and the name is not any of the fundamental HTML like tags. So it's like a random name and then it's called a primitive there. I don't remember where, but when I was reading the source code there, I think probably it was on this file, but I don't remember really well. So I want to understand more, like what is that supposed to be. And it looks like they changed here the tabs, which it is very nice. I prefer this way, I think, than the other way. It looks cleaner. The context of React primitive generally refers to simple immutable values such as numbers, strings, booleans, and nil. Uses props and state in React components, and they are passed by value rather than by reference. Primitives, objects, and arrays are considered non-primitive in React because they are mutable and passed by reference, which can lead to unexpected behavior if not used correctly. When working with non-primitives values, it's important to be mindful. Yeah, so it is what I was thinking about. But I'm not sure if I understand really well in the context of the file there. So maybe when I get to the point again, I'll ask more questions. I think at the core of the issue is that this thing here. So it's the app that is created, app renderer that is created by the file there. And how that's gonna be like handled through the life cycle of the state in the application. There's the Pixi component. And this thing here, the relationship between them.
Conceptual model of React without implementation burden. Some of this may not make sense on first reading. That's okay. It will make more sense with time. React design principles. Pay special attention to the section on scheduling. It does a great job of explaining the why of React Fiber. Review. Please check out the prerequisites section if you haven't already. Before we dive into the new stuff, let's review a few concepts. What is reconciliation? Reconciliation, the algorithm React uses to diff one tree with another to determine which parts need to be changed. Update a change in the data used to render a React app. Usually the result of set state eventually results in a re-render. The central idea of React's API is to think of updates as if they cause the entire app to re-render. This allows the developer to reason declaratively, rather than worry about how to efficiently transition the app from any particular state to another, A to B, B to C, C to A, and so on. Actually re-rendering the entire app on each change only works for the most trivial apps. In a real-world app, it's prohibitively costly in terms of performance. React has optimizations which create the appearance of whole app re-rendering while maintaining great performance. The bulk of these optimizations are part of a process called reconciliation. Reconciliation is the algorithm behind what is popularly understood as the virtual DOM. A high-level description goes something like this. When you render a React application, a tree of nodes that describes the app is generated and saved in memory. This tree is then flushed to the rendering environment. For example, in the case of a browser application, it's translated to a set of DOM operations. When the app is updated, usually via set state, a new tree is generated. The new tree is diffed with the previous tree to compute which operations are needed to update the rendered app. Although Fiber is a ground-up rewrite of the reconciler, the high-level algorithm described in the React docs will be largely the same. The key points are: different component types are assumed to generate substantially different trees. React will not attempt to diff them, but rather replace the old tree completely. Diffing of lists is performed using keys. Keys should be stable, predictable, and unique. Reconciliation versus rendering. The DOM is just one of the rendering environments React can render to. The other major targets being native iOS and Android views via React Native. This is why virtual DOM is a bit of a misnomer. The reason it can support so many targets is because React is designed so that reconciliation and rendering are separate phases. The reconciler does the work of computing which parts of a tree have changed. The renderer then uses that information to actually update the rendered app. This separation means that React DOM and React Native can use their own renderers while sharing the same reconciler provided by React Core. Fiber re-implements the reconciler. It is not principally concerned with rendering, though renderers will need to change to support and take advantage of the new architecture. Scheduling. Scheduling, the process of determining when work should be performed. Work, any computations that must be performed. Work is usually the result of an update, e.g., set state. React's design principles document is so good on this subject that I'll just quote it here. In its current implementation, React walks the tree recursively and calls render functions of the whole updated tree during a single tick. However, in the future it might start delaying some updates to avoid dropping frames. This is a common theme in React design. Some popular libraries implement the push approach where computations are performed when the new data is available. React, however, sticks to the pull approach where computations can be delayed until necessary. React is not a generic data processing library. It is a library for building user interfaces. We think that it is uniquely positioned in an app to know which computations are relevant right now and which are not. If something is off screen, we can delay any logic related to it. If data is arriving faster than the frame rate, we can coalesce and batch updates. We can prioritize work coming from user interactions, such as an animation caused by a button click, over less important background work, such as rendering new content just loaded from the network, to avoid dropping frames. The key points are: In a UI, it's not necessary for every update to be applied immediately. In fact, doing so can be wasteful, causing frames to drop and degrading the user experience. Different types of updates have different priorities. An animation update needs to complete more quickly than, say, an update from a data store. A push-based approach requires the app, you, the programmer, to decide how to schedule work. A pull-based approach allows the framework, React, to be smart and make those decisions for you. React doesn't currently take advantage of scheduling in a significant way. An update results in the entire subtree being re-rendered immediately. Overhauling React's core algorithm to take advantage of scheduling is the driving idea behind Fiber. Now we're ready to dive into Fiber's implementation. The next section is more technical than what we've discussed so far. Please make sure you're comfortable with the previous material before moving on. What is a fiber? We're about to discuss the heart of React Fiber's architecture. Fibers are a much lower level abstraction than application developers typically think about. If you find yourself frustrated in your attempts to understand it, don't feel discouraged. Keep trying and it will eventually make sense. When you do finally get it, please suggest how to improve this section. Here we go. We've established that a primary goal of Fiber is to enable React to take advantage of scheduling. Specifically, we need to be able to pause work and come back to it later, assign priority to different types of work, reuse previously completed work, abort work if it's no longer needed. In order to do any of this, we first need a way to break work down into units. In one sense, that's what a fiber is. A fiber represents a unit of work. To go further, let's go back to the conception of React components as functions of data, commonly expressed as v equals fd. It follows that rendering
Yo, Brad back.
a React app is akin to calling a function whose body contains calls to other functions, and so on. This analogy is useful when thinking about fibers. The way computers typically track a program's execution is using the call stack. When a function is executed, a new stack frame is added to the stack. That stack frame represents the work that is performed by that function. When dealing with UIs, the problem is that if too much work is executed all at once, it can cause animations to drop frames and look choppy. What's more, some of that work may be unnecessary if it's superseded by a more recent update. This is where the comparison between UI components and function breaks down, because components have more specific concerns than functions in general. Newer browsers and React Native implement APIs that help address this exact problem. Request idle callback schedules a low priority function to be called during an idle period, and request animation frame schedules a high priority function to be called on the next animation frame. The problem is that, in order to use those APIs, you need a way to break rendering work into incremental units. If you rely only on the call stack, it will keep doing work until the stack is empty. Wouldn't it be great if we could customize the behavior of the call stack to optimize for rendering UIs? Wouldn't it be great if we could interrupt the call stack at will and manipulate stack frames manually? That's the purpose of React Fiber. Fiber is reimplementation of the stack, specialized for React components. You can think of a single fiber as a virtual stack frame. The advantage of reimplementing the stack is that you can keep stack frames in memory and execute them however and whenever you want. This is crucial for accomplishing the goals we have for scheduling. Aside from scheduling, manually dealing with stack frames unlocks the potential for features such as concurrency and error boundaries. We will cover these topics in future sections. In the next section, we'll look more at the structure of a fiber. Structure of a fiber. Note, as we get more specific about implementation details, the likelihood that something may change increases. Please file a PR if you notice any mistakes or outdated information. In concrete terms, a fiber is a JavaScript object that contains information about a component, its input, and its output. A fiber corresponds to a stack frame, but it also corresponds to an instance of a component. Here are some of the important fields that belong to a fiber. This list is not exhaustive. Type and key. The type and key of a fiber serve the same purpose as they do for React elements. In fact, when a fiber is created from an element, these two fields are copied over directly. The type of a fiber describes the component that it corresponds to. For composite components, the type is the function or class component itself. For host components, div, span, etc., the type is a string. Conceptually, the type is the function, as in v equals fd, whose execution is being tracked by the stack frame. Along with the type, the key is used during reconciliation to determine whether the fiber can be reused. Child and sibling. These fields point to other fibers, describing the recursive tree structure of a fiber. The child fiber corresponds to the value returned by a component's render method. So in the following example, function parent, return child, greater than, the child fiber of parent corresponds to child. The sibling field accounts for the case where render returns multiple children. A new feature in fiber. Function parent, return, child 1, greater than child 2, greater than. The child fibers form a singly linked list whose head is the first child. So in this example, the child of parent is child 1 and the sibling of child 1 is child 2. Going back to our function analogy, you can think of a child fiber as a tail called function. Return. The return fiber is the fiber to which the program should return after processing the current one. It is conceptually the same as the return address of a stack frame. It can also be thought of as the parent fiber. If a fiber has multiple child fibers, each child fiber's return fiber is the parent. So in our example in the previous section, the return fiber of child 1 and child 2 is parent. Pending props and memoized props. Conceptually, props are the arguments of a function. A fiber's pending props are set at the beginning of its execution, and memoized props are set at the end. When the incoming pending props are equal to memoized props, it signals that the fiber's previous output can be reused, preventing unnecessary work. Pending work priority. A number indicating the priority of the work represented by the fiber. The React priority level module lists the different priority levels and what they represent. With the exception of no work, which is 0, a larger number indicates a lower priority. For example, you could use the following function to check if a fiber's priority is at least as high as the given level. Function matches priority fiber, priority. Return fiber dot pending work priority. Exclamation mark equals 0 and fiber dot pending work priority less than equals priority. This function is for illustration only. It's not actually part of the React Fiber codebase. The scheduler uses the priority field to search for the next unit of work to perform. This algorithm will be discussed in a future section. Alternate. Flush to flush a fiber is to render its output onto the screen. Work in progress a fiber that is not yet completed. Conceptually, a stack frame which is not yet returned. At any time, a component instance has at most two fibers that correspond to it. The current, flushed fiber, and the work in progress fiber. The alternate of the current fiber is the work in progress, and the alternate of the work in progress is the current fiber. A fiber's alternate is created lazily using a function called clone fiber. Rather than always creating a new object, clone fiber will attempt to reuse the fiber's alternate if it exists, minimizing allocations. You should think of the alternate field as an implementation detail, but it pops up often enough in the codebase that it's valuable to discuss it here. Output. Host component the leaf nodes of a React application. They are specific to the rendering environment. For example, in a browser app, they are div, span, etc. In JSX, they are denoted using lowercase tag names. Conceptually, the output of a fiber is the return value of a function. Every fiber eventually has output, but output is created only at the leaf nodes by host components. The output is then transferred up the tree. The output is what is eventually given to the renderer so that it can flush the changes to the rendering environment. It's the renderer's responsibility to define how the output is created and updated. Future sections. That's all there is for now, but this document is nowhere near complete. Future sections will describe the algorithms used throughout the lifecycle of an update. Topics to cover include how the scheduler finds the next unit of work to perform, how priority is tracked and propagated through the fiber tree, how the scheduler knows when to pause and resume work, how work is flushed and marked as complete, how side effects, such as lifecycle methods, work, what a coroutine is and how it can be used to implement features like context and layout. Related videos. What's next for React? React Next 2016. About. A description of React's new core algorithm. React Fiber. Resources. README. Stars. 10K stars. Watchers. 321 watching.
No, I don't know where the future sections.
As I said, my name is Andrew Clark. I'm a front-end engineer. I've been creating React apps for about 2 years now.
Very good article. So I was thinking about, yeah, I'm gonna search for what happens if React app has show different renderers. Ask ChatGPT as well. So I think the first thing that I'm gonna try to understand is this directly, and then if it doesn't work, I'm gonna have to break down, like understand the source code of both libraries, both React and React Pixi, to understand how the state's gonna change when using both of them, and then how to implement Pixi-viewport in a way that is gonna work. And I think that I have to spend the time understanding this because it is a fundamental thing. So maybe it's not very useful now. Maybe I can find easier ways to solve the problem just by trying a bunch of stuff. But then I'm pretty sure that I'm going to run into other problems in the future that are related to this because it is a fundamental part. I think this is one of the fundamental challenges that I had in the past. And the reason why I was trying to avoid using React, but I think this is not avoidable, which is when you implement the canvas when you have a website that have the canvas and you need to use React or other libraries like that, you're gonna encounter this problem, I think. So it's just clarifying the way that the canvas state is related to the DOM state. I think that's the fundamental thing, and also the server-side rendering part. So if I don't understand really well, I'm gonna keep encountering this problem. But if I understand the fundamental, then it opens up a lot of possibilities, I think, and it's gonna make things a lot easier in the future. So just worth spending the time studying, I think. Maybe this doesn't implement render as well. It's also possible. I just assume it does because of the stuff that I read so far, but it might be that I'm not that I don't understand really well how it works.
Many people don't know this, but I am one of the co-creators of Redux along with Dan Abramov, of course. Yep. I also created a library called Recompose. Are there any Recompose users out there? I know I met a few earlier. Cool, awesome. Want to talk to me about that later? That'd be sweet. So, and I also recently joined Facebook, which is really cool. I just joined last week, though, so I can't really give you any secrets yet, but I'm going to be on the React team, and I'm very excited about that. So today I'm going to be talking about something called React Fiber. And I must admit, I was a little nervous about this topic for a few reasons. One is it's highly experimental, so it's not something you can use today or really anytime soon. It's possible that this experiment will fail and you'll never get to use it. Even if it does work out, it's going to be like a few months at the very least before you can try it. And when it is released, if it's released, the whole idea is that you're not really going to notice, maybe except for your app will get faster, because really we're just going to try not to break stuff. And then lastly, it's a little nervous because I still only kind of barely understand how it works, but I'm going to give it a talk about it anyway. Having said all those caveats, I'm really excited to be here and to talk about Fiber, and I think you're going to enjoy learning more about it, because I've really enjoyed learning more about it over the last few months or so. So what is React Fiber? React Fiber is the next version of React, appropriate given the name of this conference. So now when I say next version of React, I don't mean like 16.0 whatever. I mean it's like a ground-up rewrite of React's core algorithm, of like the whole internals and how it works. And so, in my opinion, this is the most exciting thing that's happening in the React world, even though it's not going to be quite out there for a few more months. This is the thing I'm most excited about for like the near-term future of React. And I think a lot of the other members of the React team agree. If you saw Christopher Shadows' Visu's React Reflex Q&A a few days ago, he said the same thing. So quick show of hands, how many of you have actually heard of React Fiber before? I just said it right now. So okay, a few like scattered hands. So if you raise your hand, maybe because you heard whispers about Fiber on GitHub or Twitter, passing references to some new version of React every once in a while, maybe new reconciler, new core algorithm, things like that. So that's how I first heard about it too. That's because there is no real official documentation on describing what Fiber is. You may have come across a document that I wrote called React Fiber Architecture. I put on my GitHub about a month ago, I think, and that got some eyeballs. But that's not an official document. That's an outsider just trying to make sense of something that's really exciting, but still was a little opaque to me. And it remains undocumented because, as I said, it's still highly experimental. And I said that twice because I'm trying to impress upon you that it is highly experimental. So consider yourself warned. Yeah, so just a little bit of history. The React team has been working on Fiber for a while now, and even before it was called React Fiber. So I did a little digging recently. There's a tweet I recently rediscovered. I read this back when it was originally tweeted, and then rediscovered it as I was preparing for this talk. And it's Jordan Walk, who's the inventor of React, if you didn't notice, and some of the other core team members teasing here some new version of React that they're working on. And notice this was written in August of 2014, that's over 2 years ago. And it turns out that since the time that tweet was posted, React team's worked on a lot of experiments and research and prototypes of some new version of React that could do a lot of the things that are listed here in this kind of thread. And Fiber is just the latest iteration in this series of experiments. But what makes this particular experiment different is that there are actual commits right now being made to Fiber in the GitHub project that you can follow along in. So it's just getting closer to something that will actually be real. And I said it's experimental, even if this version maybe doesn't make it out. Something like it is, so that's why I don't feel too guilty showing you something that as of right now is not totally completed. But yeah, you can totally go on GitHub right now and follow along as it's being implemented. That's how I learned pretty much everything I'm about to tell you right now. So I have a few goals in this talk today. I'm going to talk like why Fiber exists, why are we rewriting React. That's one kind of point I want to talk about. I want to talk about how Fiber works a little bit, like in terms of its implementation, and then I'm going to talk about what types of features and cool things it's going to unlock. It's actually there's some really ambitious stuff that Fiber's going to let React do. Mostly I just want to get you really pumped for React Fiber. I'm like really excited about it, as hopefully you can tell, and if I can get you guys excited about it, or all of y'all excited about it, then I'm going to consider the talk a success. So first, why rewrite React? So there are a few reasons. We're going to start first with the topic called scheduling. So scheduling. It's a term that can mean different things in different contexts in the world of computing, but it's the process of determining when work should be performed, essentially. When I say work, I mean just any kind of computation. In the context of React, that's work we'll refer to like reconciliation, virtual DOM diffing, and just rendering. That's what work is. So scheduling in the context of React, what does that mean? Well, essential idea in React is that UIs are expressed declaratively, of course. So rather than having to imperatively mutate the DOM, you can return a description of your UI for a given set of data. Right? That's the core premise of React. And that means you don't have to worry about how to efficiently transition your app from one state to another, from A to B, B to C, C to D, X to G, whatever. React just takes care of all that for you. So this leads to some really big wins in how we structure our apps. I'm not going to dwell on this too much. Everybody, this is an advanced talk. Everyone here's used React before, I hope. So I'm not going to dwell on this. We all know that components are awesome to work with. Aside from being a better paradigm for developers, this declarative nature of React gives a really nice feature of this declarative nature of React is that it gives React control of scheduling. React gets to not only decide how to update your UI, but also when to update it. So to put this in a little bit more concrete terms, what that means is when you call set state, the concept of set state is not so much you telling React, hey, render this component now. I mean, in effect, that's what happens, but that's not really the concept of set state. It's more like saying, hey, this component has changed. Do what you need to do to update the UI whenever you think is best. That's a little bit like a more accurate way to think of set state. If you've ever heard the terms push versus pull, that's what this idea is referring to. A push-based approach requires the app, by which I mean you, the programmer, to decide how to schedule the work, how to decide when to perform certain types of work and when to not. A pull-based approach is when the framework, React in this case, is when the framework is allowed to be smart and make those scheduling decisions for you. So React is a pull-based paradigm rather than a push. An example of a push-based paradigm would be any of these like FRP-style UI libraries like Cycle, for instance. So what's special about this idea? For one, it gives React the ability to prioritize different kinds of work. So let's think about what we mean by that. Think about the different ways that updates, re-renders in a React app can be triggered. So there's user events, as in like clicks or like a form input change. There's external data subscriptions via like Redux or Relay or MobX or anything like that. And then there's animations, for instance. So this is element transitioning from one thing to another. Perhaps you're performing some sort of gesture and you want to animate that and make it look really nice. Now, because the current version of React doesn't really take advantage of scheduling in any big way, all these different types of re-renders that are triggered by these different types of things are treated exactly the same, essentially. When set state is called on any component, that component and its entire subtree are recursively re-rendered synchronously until there's just nothing left to render. But if you control scheduling, what that allows you to do is give higher priority to some types of work over others. So for example, if you have two pending updates that need to render, and one is an update that is triggered by new data in a Redux store, for instance, or in your Redux store, for instance, and the other one is a re-render caused by an animation that's happening 60 frames a second. And you have these two updates that you need to render. Which one should come first? Which one is more important to render quickly first? The Redux store update or the animation? So the answer is the animation, because if an animation drops frames, that leads to a bad user experience. Whereas if it takes one extra frame for your new data from the Redux store to appear on the screen, no one's going to notice that. It's going to be imperceptible. But drop frames, people notice that pretty easily. That leads to a bad user experience. So keeping your animations fluid is really important. This might seem counterintuitive, of course. You might be tempted to think, well, Redux data is more important than that's the important information. The animation is just visual fluff. But in terms of user experience, a janky animation is much worse than just like an imperceptible delay of when data appears on the screen. So essentially, without scheduling, all updates are going to be treated equally, applied immediately, regardless of their priority. You're just going to apply them all at once. With scheduling, different updates have different priorities. Here's another example when this is important. When you update a component and it's not currently visible on the screen, how efficient is that? Not very efficient, right? Like, it doesn't make sense if the component on the screen to immediately start rendering it. So this issue comes up whenever you're dealing with list views, right? This is a very typical situation people get themselves into. You have like 1,000 items in the list. So this is just oh shoot, sorry. This is how did I get there? Okay, I don't know why this isn't playing, but there we go. So if you have this is just movie of React Virtualized. If you guys have heard that's a pretty cool virtualization library for React. If you have 1,000 items on a list and you don't want to account, and you don't do anything to account for all of the items that are off the screen and those renders, then you're doing a bunch of wasteful work and your app's responsiveness will really suffer. So one thing you can do to help with this is deprioritize any of the items that you know are off screen until after the on-screen work is done, and that will prevent some jankiness. So React Virtualized actually does this. It does something called windowing, where it just doesn't render items if they're too far off screen, which is that's also something we're going to do, and it's something that Fiber will actually help with as well. We'll talk about that later. But this is one example where you definitely want to deprioritize off-screen content. And if you have a scheduler that can prioritize different types of work, then that's something you can do. So I'm going to show you an example. You got a little peek of it when I made a particular. I'm going to show you an example now of Fiber and how this prioritization concept comes into play. Now, as I said like 5 times already, Fiber is still very new. So this demo might seem like weird. Like, why are you showing me this weird triangle demo, Andrew? This is kind of hopefully I can communicate to you like what this demo is trying to show. So is it playing? Okay, so let me explain this. It's a little weird. So we have this giant triangle, and each one of these blue dots is a React component. Some things to know about this demo, because it's a little bit contrived, because no one's going to build it out like this. I mean, it does look cool, but no one's going to build this out. One of the things that you should know is that in the render method of each one of these little dots is a giant while loop that iterates through like, I don't know, like 100,000 iterations, just completely wastefully, just to simulate like a really expensive render. That's one thing to know. Another thing to know is if you notice every second there's a number on those dots that's incrementing. Essentially every second the entire tree needs to be rendered so that we can get the new numbers on those dots. And then the other thing you need to know is you can notice that the entire triangle is shrinking and expanding just constantly on every frame. So the way we're doing that is on every single frame, 60 frames per second using a request animation frame, we're re-rendering the topmost container and just setting a CSS transform to like scale the container so it shrinks and expands. And since it's the container, and because with React, as you learned from Boris' talk, if you were here for that, when you re-render a container, all of its children also update. So essentially on every single frame, we're calling render on the topmost component, which of course triggers the entire thing to render. So you can imagine like rendering all of these components and knowing that the render is really expensive because we did that crazy like 1,000 wasteful loops thing. If you're not careful, this can be really bad. Fortunately, we're using Fiber here with prioritization scheduling, so it actually works really well. It's a little bit jank, that's just the video. It looks very smooth if you look at it on the computer. I'm going to give you a peek of what this looks like if you don't use scheduling, and that's this. So here, you can notice it's not expanding and contracting anymore. The numbers are just totally frozen. These colors I forgot to explain, that's a visualization of the reconciliation going on. It's not even getting down to like halfway through the entire tree. So that's me making a mistake with the recording, but it's not even getting down like all the way to the bottom of the tree because it's trying to re-render like every frame, and because there's no concept of like deferring work, it's like getting stuck trying to get all the way down the tree before the next update comes in, and ends up wasting a lot of work. Whereas in the Fiber version from before, what we were saying is deprioritize everything except for the topmost animation where you shrink and contract, get to that other stuff later, and just prioritize that fluid animation because that's a lot more important than the every second tick thing. So if that didn't make sense, hopefully it will a little bit better in a bit. It's hard to explain in words, but we'll get into more than nitty-gritty. So related to scheduling is this concept called concurrency. And this really gets to the heart of Fiber and what makes it so powerful. And notice I didn't say parallelism, I said concurrency. This is also happening in a single thread. So let's talk about what this means. So remember that in the current version of React, as we just discussed with that triangle demo, a call to set state causes an entire subtree to re-render synchronously and without interruption, essentially. There's some batching, but for all intents and purposes, it's synchronously without interruption. But what happens if you're rendering something during animation, right? And you're between two frames. Typically there are 60 frames per second, as we said, so about 60 milliseconds. Every 60 milliseconds animation is Fiber. But say when that deadline comes, you're still busy rendering some low priority work. So it's time for a new animation frame, but you're busy rendering something that's not all that important, like something else off screen, for instance. In order to do prioritization scheduling, we need some way to be doing that low priority work and then interrupt it, perform the higher priority work, and then come back to the interrupt work and resume rendering so that it doesn't just stop completely. That sounds pretty tricky, right? How do you interrupt a rendering component? So let's think of this way. So not really React presentation, so someone throws some version of this formula on the slide. Conceptually, of course, we think of React components as functions of data. And the tree of React components is just some nested function calls. And rendering a component is like calling a function. So in this conceptual analogy, which is really important as we move forward, components and functions, what we're attempting to do is interrupt a function call. Remember, we're going to pause the component rendering. That's in our analogy. That's like interrupting a function call. So how do you interrupt a function call in JavaScript? Anyone think of a way? Some generators? Yeah. So yeah, generators. JavaScript does generators, and you can interrupt them. In fact, generators are used. I think a lot of generators are used to implement like concurrency because anyone use co or anything like that, or blue respond, I think is what it is. So yeah, generators do exist. It's not quite what we're looking for here, I'm not going to explain why, but that is one way that you can implement concurrency in JavaScript. How about this? If I go to debugger statement, another function, right? I'm going somewhere this by the way. So yeah, if you drop debugger statement in your function, or you create breakpoint in DevTools, it's going to pause the function execution. Just keep with me. And so if you do this, you'll see it like this. This is the call stack on the left. Each frame's return address points to the frame below it. And then on the right is some information about the current stack frame scope. And there's a blue button, and when we click the blue button, the function continues executing. So obviously we can't use debugger statements implementing concurrency in our UIs, but I'm using this example to illustrate that this is basically what we're trying to do, right? We're trying to pause function's execution or component from rendering, and then resume it later when we feel like it. So that's essentially what we're trying to do. It's actually a little bit more complicated than that. It's a little bit fancier. What we're going to do is interrupt the current rendering call stack and stack that call stack over to the side somewhere. Then you have some higher priority work that we need to do. So go do the higher priority work, has its own call stack, and go all the way through it. And then once that higher priority work is done, like animation is done, go back to the original call stack and then keep going from where you stopped before. Okay, so this might sound pretty crazy, but this is essentially what React Fiber does. It pauses work, completes some of the work, and continues later. Except in my little example, we only have two things. Fiber can switch between like limitless numbers of things. There's no limit how many call stacks you can work on at any moment. So that's what Fiber is in some sense. It's a reimplementation of the stack specialized for React components. You can think of an individual Fiber as a virtual stack frame that helps where information in the stack is preserved in memory on the heap, and because stack frames are preserved on the heap, you can manipulate them as data structures and execute them.
From other videos that I saw, it looks like they changed this as well. Now it's not a stack anymore, it's something else. But I forgot exactly what they're using now. But I think they changed from stack to something else.
You want, and you might imagine when you control the stack like that, you can implement all sorts of clever concurrency features on top of it. So that's another way to think about Fibers is that they are a unit of concurrency. So just as an aside, like some of this is, if you're having trouble grasping like what this is, you're not familiar with concepts or something like that, don't feel bad. Like I myself barely understand it. Fibers are really a language level concept. They're low level abstraction than UI developers typically think about. Fibers and React are heavily based on Fibers and OCaml actually, where you implement sophisticated features in that language, sophisticated concurrency features in that language that there's algorithmic effects and those are. So this is really language level stuff. So don't be like feel upset if you like don't totally grasp it immediately. So here's like a table I made to kind of compare like a stack frame to a Fiber and see how they're similar. So in a stack frame, every stack frame like corresponds to some subroutine or function. In Fiber, that the conceptual analogy would be Fiber has a component type, right? That's kind of like a component is a function. In a stack frame, you have like the body of the subroutine, which contains nested function calls. In Fiber, those nested function calls, the analogy is just children essentially. A stack frame has a return address so that the program knows where to return after the subroutine exits. For Fiber, that's essentially just your current component, right? Whichever component comes out in the tree. A stack frame will have arguments into that stack frame, into that function. And the analogy, of course, for a component input is props. And the stack frame has a return value, and Fiber have eventually a React component corresponds to some resulting down output. So this is a little bit like a high-level overview. I'm not going to go too far into detail against the exact implementation details. Sure, going to change many times before fiber release, but this is just a general sense of how stack fibers are very similar. But fibers also have some deals that are specific to React components. Don't really have anything a lot. For instance, there's priority. As you mentioned, every stack frame has a number that indicates what level of priority it should have relative to other kinds of work. It has a field that contains like a minimalist input. So this allows React to say, okay, so the input hasn't changed. I don't know why you're doing this. I can save it. It has a key. So now React elements have a key. That's really important when you're performing doing virtual non-dipping or reconciliation because the key when you have those values is what tells React what position that item should be in the list. So yes, to repeat, fibers are a unit of concurrency and they allow us to break work into chunks. And this is really crucial for implementing scheduling and prioritization that we discussed a little earlier. You can't prioritize work unless you break it into units. So this is another piece we need to do scheduling properly. We have strategy for prioritization. Fiber has a method of assigning priority to different fibers. We have a way to break work down to units because fiber is going to be our unit of work. We also need a way to determine when to actually perform that work and when to yield to the event loop so that we can continue it later. So let me try and explain that a little bit more. So modern browsers give us two APIs for doing the scheduling work at the ideal times. Request animation frame and request callback. I think most people know what request animation frame does. It's called every frame, typically like 60 frames per second. You use that to schedule work that has like an animation level that really high priority. Of course, you can call names for animations. And request callback. This one might be a little bit newer to some people. I think it's only in like Chrome maybe. I'm not sure. It doesn't have as much implementation in browsers yet. This is a really important API as well. It schedules callback to be called during browser's idle periods when it's not doing anything else important. And use this to schedule all work that is lower than animation priority. So basically, anything that's on animation, we schedule using request callback. And the neat thing about request callback is when it calls callback, it provides an API, like I said, an argument, it provides a deadline API that lets the callback know how much time is left before the idle period is over. So you can imagine these idle periods every once in a while in the timeline of the browser. Request callback lets us know like when we're heading up to like the end of those idle periods. That way we can stop performing work, yield back to the event loop, and then we can pick up later when the next idle callback begins. So yeah, this deadline is what lets React Fiber know, hey, let's pause rendering for a bit, see if there's anything else more important we need to do and continue later. So here's a very high fidelity visualization to show you kind of what this means. This is going to illustrate how request animation frame and request callback allows you to yield between high priority work, low priority work. So say you got like 40 units of work, low priority work you need to perform. Diagram on top shows that without yielding to the event loop, you can have perform in kind of the current model of React, you have to perform all of that work all at once. You know, interrupting it. You have to perform all that work at once before you can animate a single frame, right? Whereas if you on the bottom diagram, which is able to yield, then you can split that work into 4 chunks, and you can still animate those frames in between. So in the top version, your animation is going to look really jaggy and awful. On the bottom version, we're still able to interrupt, we're still able to animate these frames without like stopping the other work. It just happens a few frames later, but this is low priority, so we don't notice. So now animation will look much smoother. I'm going to make user experience. So this is a bit simplistic, but should communicate the basic idea. So as I said, browsers implement request callback. You kind of make it, it's not really good as a proper version because it's really only the browser vendors can tell us like when there's an idle period and when there's not. But you know, even our version can be better than every other. Hopefully, browser vendors will have this API really quickly. It's very important. So now I'm going to talk a little bit about some other features that, and this is a pretty cool theory, some of this stuff. I want to talk about some of the concrete features that, besides making out this stuff, some concrete features that the concurrency stuff can enable. So there's one particular feature that I'm really excited about, and that is integrated layout. So this is not going to be an initial release, but it's one of the goals that React team had in mind when designing Fiber. I can't put much on it, but the gist is essentially that Fiber has a new concurrency primitive used internally called coroutines. And coroutines allow back and forth yielding between child and parent components. They're not used for feature, but they're used internally by React to implement layout primitives, just like lots of other types of layout algorithms that you can imagine. So practical example for why you want to do this is, as we discussed earlier, table virtualization. So table virtualization, that windowing algorithm is a lot easier if you don't have to read from the DOM constantly like how big certain elements are. As Boris said, talk before mine, as reading very slow. If we control the layout information ourselves, that just removes the entire reason to ever have to read from the DOM. So React can figure out which items will be rendered for each position. And this opens up a lot of doors. Controlling layout opens up a lot of doors, features that work previously feasible, and it's only really possible by having this concurrency, this ability to have concurrency. So okay, so this makes sense to have React kind of take over the layout for the elements on your page. Keep in mind that React Native is already kind of doing this with it has its own implementation of CSS and it's been pretty successful. So I'm going to keep in mind if you're recoiling forward about React taking over another thing that the browser used to do. So I'm pretty excited about that. And then here's some other miscellaneous features that are possible. One is returnable elements render. It's a very often requested feature. This isn't really totally related to fibers or concurrency or anything like that. It just happens to be really difficult with React's current implementation. If Fiber takes a while out, I think the plan is to implement this on top of React as it is today. But this is going to be nice because sometimes I think everyone experiences this where sometimes you want to return maybe like multiple items in the table, you like wrap it in this div element and it's, or span is very necessary. It creates these junk elements that really do nothing scattered all over your app. Sometimes if you're using CSS or tables, it can mess with the layout or flex up to mess with the layout in unpleasing ways. So this is going to reduce the number of unnecessary wrap elements in your app, and especially this integrated layout thing of the thing is going to really reduce the number of divs or things that you need. Because think about how many divs in React is only for just defining layout thing, right? React control the layout itself, and you have to use these like entity builders to nothing to deal with. So the goal is that apps really in terms of like mobile app experience. So I'm going to love the class. To repeat, Fiber is highly experimental. I'm going to do that 10 times now. Because it's really some feature like some versions of like Fiber, like these things are very important to React team and Facebook. So Fiber itself in its current form is eventually becoming something like digital. Another way is this current Fiber is being less faster on my page. I'm sorry, faster because the total means the team after my boot. Kind of confusing parts of the application now. It's kind of fresh beginning, perfect to default. So yes, that's everything we can.
Format such a utilization officially.
It's possible it's not in a render, so that's another subtle thing I break. So there are some weird cases. In general, if you're following the path, you're not doing anything to outside the lines. Hopefully, that is that everything will work. But if you're doing anything inside the pattern, it's possible. You're great. Any other questions? Like time stuff. I'm just going to
Hey, I'm not sure if you can answer this question, but it looks to me that the community gets to the age of dealing with the limitations of language and browser. It looks like the community puts a lot of effort in dealing with the things, like the lack of threading and other things. Do you know if there's some, I don't know, improvements to the browsers that are coming out for the language or something?
yeah, so this is really, I'm really probably not going to answer this. This is like a Sebastian question. So again, caveat that I don't want to talk about right now. I think there is.
So today we're going to talk about a subject I personally really like, and that's React.js. And not just React.js. We're going to try to understand what's going on inside React, how it works, a bit about the internals and the stuff inside it. So when I was doing this lecture, I started from something that might sound weird, and that's interview questions. A lot of people come to Fiverr Tech to interview, and if you want to do React, we usually ask them one question. Why did you choose React? Many people make different answers, but the most common one is because of Virtual DOM. All right, Virtual DOM. So what is Virtual DOM exactly? I heard lots of different explanations of Virtual DOM. Most of them were kind of not correct. But even if someone tells me the correct answer, I would ask them, but why would you need Virtual DOM? What does it do? And usually there, people can kind of stutter and fail. So what we'll try to do today is to really understand what Virtual DOM is, why is it used, and how it can be important in your everyday work. So I think the first thing to say about Angular is that it's not a simple framework. If any of you ever tried opening the source code, looking inside, you've probably seen a lot of code, and it's complicated code, not something you just read and understand. Usually there are about 2 different reasons for code to be complicated. The first one is when someone is doing really bad architecture, and the second one, is when someone does a lot of optimizations. I guess you know which one is the case for React. So a few words about myself after Adam's nice introduction. My name is Boris Zinkovich. I've been developing since I was about 11 years old. I started with Basic, not Visual Basic, with old style Basic, which I still hold dear to my heart. I've been doing React for about 2 years now. mainly with Redux and all the cool other stuff behind it. I started, as many of you probably did, with Angular and other frameworks before it, but I don't think I want to look back anymore. I'm one of the co-founders of Tech, a company that specializes in building frontends for other companies, both in React and Angular, and now with Angular 2 as it comes out. And I really like cats, so I was trying to add a lot of cat photos to a lecture, and I only managed to find one, unfortunately, but what can we do? So I think the very important thing to understand about React itself is React is all about JavaScript and trees. And what I mean about that is, does anyone not understand what this is? Anyone? Perfect. Everyone are good React developers, very good here. So this is a very basic React component. It's defined as a very simple function. It uses J6 to define what exactly you want to render. Nothing special about it. As you all probably know, this is J6. So this is not JavaScript. This is not what the browser sees and executes. What the browser sees is something like this, which is exactly the same code just after J6 has been resolved to JavaScript. It's basically two nested calls to React create element. And since React is very simple, if I take this and just go to the Chrome developer console, I can run the to-do function. And what I get is really the structure of the DOM we want to build. So we have an object of type URL, and inside of it we have an object of type li, which has inside of it a string. So exactly the same thing we've seen in the definition. Why did I mention this? Simple. So you know, if I want to render a component, I just run the function, or in case it's a class, I just run the render function. No complications here. That's the easy part. So back to my original question about why would you want to use React? The common answer here is because the DOM is really slow. So we all know that it's not a surprise, right? DOM is not a fast animal. Any changes to the DOM might require the browser to do a lot of work, a lot of rendering, applying CSS, calculating style, calculating sizes, a lot of difficult work. So if you can minimize the number of updates to the DOM, we're going to have a very fast framework. So I was thinking about this thing and I said, you know what? Since React uses J6 and doing that, using J6 to generate those DOM trees is really easy, might be just run the render function. How about we try to build something for our own? Instead of all the huge code base of React, we'll just build something simple. So I want to build a simple application. It has only a few components, an app component, which has a header and a list of to-dos, and so a component for each to do. Let's see how it should look when you use DOM. So this is exactly the same instruction before. Now I specified exactly what kind of DOM components I want to use. So my header is div with h1 and welcome inside, and my to-dos is basically a UL with LIs. Very simple. What kind of DOM should we expect from this tree? Well, exactly the same one, right? The React DOM, the React tree, and the DOM should be very similar one to another. So far this looks very simple. So if I want to create a basic framework that's similar to React, all I have to do is call the render method of app, right? Make sure recursively to call render of all the underlying components, then take this tree, look only at the DOM elements inside, and then just put them inside the DOM. Very simple. And if tomorrow someone wants to add one or change one of the tools, I'll just call this rendering process again, compare it to what's happening in the DOM tree, and if something changes, just update. So if someone changes one to uno, I'll just go here and change the inner text. Sounds pretty simple, right? We're comparing two trees. So I would like, this is like official introduction happening today. What is JS? It's coming to the world, yes, a new flavor of React. And it's very simple. All it does, it calls render. We'll use the same J6 syntax to make things simple. All we do is call the render method. We build the whole tree. I'll call it the future tree. Then we just compare stuff to what's happening inside the DOM, change what's needed. Success. All right, so far I was really excited about the first version of JS, but I remembered that I used to read something in the React docs that said a very weird line that reading from the DOM is slow. Now I remember reading that and said to myself, that doesn't make sense, right? So the browser already built the whole DOM tree. If I'm asking now about the size of elements or what kind of classes there, it should be instantaneous, right? There's no reason for it to be slow. So my initial plan was to create a PR and fix the documentation. A rule of thumb before you submit a PR is to test, right? And I decided to follow that. So I created this nice function. So this function is not used inside JS. All it does, I give it a node in the DOM tree, I give it a value, and it just checks if a value is not what I want it to be, set the value to the new value. Really simple. And I thought it might be interesting to run a speed check. So this is the result. Again, this is running on one of the latest MacBook Pros. Updating 100 nodes, checking and updating them takes about 5 milliseconds, which doesn't sound like a lot, right? 5 milliseconds is almost nothing. But if you think about what will happen if you run it on the browser on a mobile phone or something, it might be 10 times more. But if you're running it 1,000 times on my virtual machine, we get about 3.6, 36 milliseconds. Again, it doesn't sound a lot, but if you want to have a nice page with snappy responsiveness, we're supposed to get to 60 FPS. That means we have to do 60 frames per second, which leaves us about 60 milliseconds for everything. And that's application logic, animation, updating using the framework, and all the other things. So the figure of 36 milliseconds is suddenly appalling. So we have a problem here. Apparently, updating, reading from the DOM, updating, reading from updating is really slow. So I thought maybe it might be nice to do another test. How about we check how long it takes to make 1,000 reads and how long it takes to make 1,000 writes? And suddenly, things are looking much better. Like only 3 milliseconds for 1,000 reads and 1,000 writes. So there isn't really a problem reading from the DOM. There isn't a problem writing from the DOM. The problem is reading and writing from the DOM at once. And why is that? Well, if we change something and try to read it afterwards, the browser might need to do some calculations before it can give us a new result. And if we do that 1,000 times, that might end up with 1,000 calculations. Okay, so our listening knowledge is set right. So if you can do as many reads as you want and then do as many writes as you want, how about instead of reading the DOM and updating it, what we'll do is first read all the information we need from the DOM and compare it to a temporal tree. So I'm happy to announce the second version of JS. And this is moving really fast here. As progress should in the report. So what we're going to do is call render to build the future tree. And then we're going to read the whole DOM. Let's go line by line, read the whole DOM into some kind of current tree that represents what's happening in the DOM. And then we're going to compare not directly against the real DOM, but rather against the temp tree. And when the change is needed, we're going to go to the DOM and update. So what does that mean? That means we do all the reads in advance and all the writes after. And as we've seen, the performance should be really, really good. And that's how we'll just do operates. And I think it's pretty good. But then I had another idea. So we can just take that. We'll just render the whole tree again, compare it again the current tree, update the DOM, and go to 2.0. Save inside the state. So if we call set states and change it from show hands, who things will see only one. And let's go and update the second possible. It's pretty simple. Once I call to React DOM, net React Native, now we're going to use React Native as well. In React Native, this is a screenshot from the React docs. There's moved inside the renders. We're not an update to view. React doesn't care. You can do as many clicks as you want. You can do this update, okay, but the whole is becoming a bit like a thinner layer, generic layer. It's still alive, but if you're looking for some complexity, you can find it hidden somewhere inside of this. All right, so we spoke a lot about how the initial rendering happens, but I think the more interesting thing is what happens when we want to update something. Well, this is a simple line of code count. As you can see, the basic React now is about, let's say, 11,000 lines of code, and the DOM render alone is bigger than the whole React. It's not going to run, because the underlying layer is going to send us a press event, and React doesn't know that the press and click is the same, so we're not going to get it. So if we want to use React on both native and DOM, we'll have to do different click and press events. Why did I start explaining this? Because the actual connection and the rendering is a bit more complicated. It's not just adding components to the DOM, it's also registering events, it's resolving graphs. It's a lot of work that the rendering layer needs to do to properly connect React to the DOM or native or whatever. And even the small things like this event loop that we spoke about now is quite complicated. This is a screenshot from the React docs, so React code, explaining how the event management works now. As you can see, it's not that simple. So under the whole React does a lot of work, and that left me with a feeling of, so if all this is happening somewhere in the renderer.
This is interesting. I think it's related to the stuff that I am trying to understand. React events listener, I think. React event listener. React events. I think I'm gonna take a picture of this. Maybe watch that again. Is that at slower pace?
know what's going on inside. So there are a few reads, but React is trying to keep as little of them as possible. Right, so we spoke about Boris.js a little bit. Let's now see how exactly this thing works in React. So we said we have two different cycles. One is the initial rendering time, and the second is updates. So the first one is pretty simple. It goes up like this. We have a mounting tree here, so we start, of course, from the top. We're going to render up.js, and as we go down the tree and render all the components, we'll see that React is basically using document create element to build DOM elements. It's building h1, it's building a div, and slowly it's building up this whole tree as rendering processes, and we end up with a tree that's very similar to what we expect, right? Exactly the same DOM elements. You remember your index.html where you put some kind of div and plan to put React inside of it? Well, the connection is pretty simple. Once you call to React DOM, it's going to connect whatever we rendered using create element and app, and connect it back to this app. And this is the whole flow. The DOM is ready. It's as simple as that. Actually, anything special about it, we could have implemented it ourselves. But, so this is the time to stop a little bit and talk about React DOM. So in version 0.14, the guys at React decided that React is good for a lot of things, not just the DOM itself. So I said, let's split, we'll create React and React DOM, and then we can add React Native and the same rendering platform for Windows or for many other things. And people are slowly adding more and more renderers. And this split made the code a little bit more complicated because React now is a very generic platform, and you can connect any renderer you want to it, and React just provides services to it. But let's see how it affects us. Let's say we have a component we defined an on-click event handler, right? So what happens now inside of React and React DOM is that a DOM event, when there's a click, it sends a click to React DOM, which in turn sends an event to React, and it's up to React to send those events to us if registered on click. Let's say that tomorrow we're going to be using React Native as well. In React, in regular DOM, we have an on-click when you click something. But in React Native, if I have a button, it's on press. That means that the renderer for React Native is going to send a press event. We all heard about reuse, so I'm going to take the same component, the same on-click handler, and try to compile it now for React Native. Let's say I do get some kind of button that's clickable. Do you think that clicking on it will cause one click to run? In React Native, we said React is reusable, can run on multiple platforms. So the surprising thing is it's not going to run because the underlying layer is going to send us a press event, and React doesn't know that we press and click is the same, so we're not going to get it. So if we want to use React on both on native and DOM, we'll have to do different click and press events. Why did I start explaining this? Because the actual connection and the rendering is a bit more complicated. It's not just adding components to the DOM, it's also registering events, it's resolving refs. It's a lot of work that the rendering layer needs to do to properly connect React to the DOM or native or whatever. And even the small things like this event loop that we spoke about now is quite complicated. This is a screenshot from the React docs, so React code, explaining how the event management works now. As you can see, it's not that simple.
I think I'm just gonna write down all of this stuff here, just search later. But this is exactly what I was looking for. Because it's the stuff that I need to understand more to think about how I'm gonna investigate the flow of the execution there. When I'm getting the problem with the wheel event. I'm gonna have to think about solutions that don't require me to change the source code of the library, the React Pixi library. I think that's going to be the tough part.
So under the hood, React does a lot of work, and that left me with a feeling of, so if all this is happening somewhere in the renderer, what's left from React itself? Well, this is a simple line of code count. As you can see, the basic React now is about, let's say, 11,000 lines of code, and the DOM renderer alone is bigger than the whole of React. And if we add all the shell stuff connected to renderers, then the whole rendering thing is more than twice bigger than the basic React stuff. So a lot of complexity has moved inside the renderers. React is becoming a bit like a thinner layer, generic layer. It's still alive, but if you're looking for some complexity, you can find it hidden somewhere inside of this. All right, so we spoke a lot about how the initial rendering happens, but I think the more interesting thing is what happens when we want to update something. Can anyone tell me what will cause React to update the view? Update should props update, no, okay, but who's going to cause the props update? State changes, what else? I heard events, I have user events. So if you're talking about Angular, which is a good example, Angular listens to everything. If you have an Ajax call, a timeout, a click, whatever happens, Angular checks what's going on and updates the view. React doesn't care. You can do as many clicks as you want, you can do as many Ajax as you want, nothing will update. There are only two things that cause React to start updating itself, and that's a call to set state and a call to force update, nothing else. If you have a click handler and you do not call set state or force update, React will not update. You have to be very specific. The plus about this is that we know exactly which component to start rendering from, right? So if I call set state on the component, React knows it has to update that component and only that component, and maybe the stuff below it. So let's make an example, try to see how it looks. This is a bit more complicated example. So we have, here's the JS6 tree. This is our code. This is the previous, let's say, virtual DOM representation, and this is the DOM. These two are obviously the same, right? Because they should be the same. Otherwise, we have a weird problem. And we're going to call a set state on my to-dos component and change it. So the flow is pretty simple. React starts rendering at the to-dos, not at the root. Exactly if the component is changed. It now, when it goes to render the to-do components here, it passes different props from what it was before. And when we reach the button, React is going to make a check. So now, what inside the VI is uno, but the previous value was 1. That means we have to go and update the DOM. And we're going to do that. The same happens for the second to do. So an interesting thing to note here, I remember I was reading tutorials when I was beginning, and I always assumed that what React does, as it does the rendering process, is create some kind of change list, and then applies it as some kind of batch operation, which is actually untrue. As React runs the rendering, every time it notices that something is different from what it should be, it just does it immediately. So if we could run the whole rendering process in slow motion in our browser, we would see things slowly changing as React is running on them. There is no change list, there's nothing like that. Everything is immediate, which makes things a lot simpler. All right, so we've done it one time. What happens if we do the same call again, same state, exactly the same parameters? Well, this time the flow is much simpler. React will notice that we want to put Uno here. It's already Uno there. That means nothing needs to be done. And that's the power of a virtual DOM. We don't have to touch the DOM at all. We know immediately that no change is needed. One important thing about React is also the lifecycle. Right? We didn't even speak about it. React allows us to know for each component when it's going to be created, when it's going to be destroyed, when it's mounted. In reality, the lifecycle events are pretty easy. Some of them run immediately. Some of them React batches in transactions, which we'll talk about in a moment. But there's no special magic here, so I'm just going to run through them. So I think the most interesting thing about React is trying to group multiple updates together. Just imagine that we have an application, I click some button, maybe a refresh button, goes to the server, fetches a whole lot of data, and then we have to update the UI. Many times updating UI is not updating only one thing. It might be updating multiple stuff. Let's say in my to-dos example, I added 2 more to-dos, I have a notification bar when I want to add the total count of to-dos, and maybe somewhere on the footer. So I might have 3, 4, 5, even 10 changes as a result of one data fetch. So let's look at a very simple example. What we have here is a call to set state on the to-dos, a call to set state on the app, and then again a call to set state on the to-dos. Why? Because our code is not optimized and we're having set state 2 times on the same component. It can happen. It can happen. So let's try to see what happens when we try to run it one line after the other. So first React is going to try to set state on the to-dos, right? In this case, it's going to run the random method of to-dos, and then the random method of to-do because it's its child. The total number of renders so far, 0, 1, 1. No surprise here. What happens when you start running the app? The same. It calls the random method for app, which calls the random method for to-dos because it's under it, and then the random method for to-dos. So suddenly we ran random twice. And lastly, we run the same for to-dos, and it's not surprising that the end result for these 3 set state calls is that to-dos and to-do got its render called 3 times. And when it's render called, comparison to virtual DOM, updates, a lot of work has been done. While this thing might work, this is obviously not a perfect solution. There has to be some kind of improvement on it, and there is, and it's called transactions. The idea of transaction is, let's take a look again at this code. How should React know that we want to run 3 set states and only then update? Maybe we have 5 more coming in a few milliseconds or 10 more. One solution would be to say, all right, we can have some kind of interval running every millisecond and flashing all the changes up until now. Not the best way to do it. So we have to be explicit. We have to tell React, you know what? Don't use do this set state now. Wait, I have a bunch of stuff I want to run, but when I'm done, update with you. And there's a thing called, it's called transactions. It's part of the React core. It's a generic thing. So transactions not just for rendering. They're used throughout React in many places, mainly in the DOM render, in other renders. One of the uses is really the update here. So the idea of transaction is simple. It means we want to run some code before to prepare, then we want to run our set states or whatever it is here. And once we're done, we want to finalize, do the cleanup, do the updates, whatever it is. In our example, we want something like this. We're going to prepare our code because we're going to run all the set states we need, and we're going to build the list of all the changes we want to apply. And once the transaction is finished, we're going to try to update the DOM and calculate what's going on. So let's take a look how it works. In React, there's an array, and its name release dirty components. That basically contains all the components we want to update. So it adds the to-dos as a dirty component release, but it does one more thing. Because we want to change the state to something new, we also want to add inside the dirty component a list of pending changes we want to make to the state. So we want the state to become this. All right. Nope. The second one is a set state on the app, so we just go and edit the dirty components. And since we want to do a change of state, we're going to add this as well. What happens if on the third one? Well, React is smart enough to know that to-dos is already in the dirty list, so we just adds the new state, the latest state we want to change. And that's our dirty list. Now our transaction is finished. That's all we want to run. So let's go to finalizing the transaction and see what happens now. So this should look similar. It's what we did before we used transaction. And so we see we have to-dos, right, and up inside here, which is exactly the same as here, to-dos and up. So let's make a run of it. First of all, we have to handle the to-dos. We go to do, and what we do now is basically run about through a list of the states and calculate the final state of the component. We're not going to update for the first state and then update for the second. We'll calculate the final state and only update our element with the final state in mind, which causes one render of to-dos and one render of to-do. So good so far. Next, we have to handle the dirty app component. Again, we calculate the final state for the app, but suddenly we have a problem because the app's rendering method renders to-dos. It might be passing in props because of state change. So we have to render to-dos again, and by proxy, render to-do. So again, we have multiple rendering. It's better than before. Before we had 1, 3, 3, now we have 1, 2, 2, but it's still not optimal. So what is the solution? And actually, there is a surprising solution. What the guys did is while you render components, React marks each component with order. So we know exactly which order we created. I know who's the father and who's exactly before. It might surprise you in some edge cases. So this is a very simple example of transaction React. One question I've been asked when I think about it is that what causes transaction, and transaction anything is kind of most of the basics of the work. I hope it will be easy in the future. Any other questions? Perfect.
חברים, מי אכל מהסלט קינוח? ברוך הצהריים בבקשה. שעה, שעתיים, תדאגו להיות קרובים לאולם בי. שלום לכולם, אני מדבר בעברית. Hello React Next 2021. Today, if you've seen my title, I'm going to talk about viewing the beast or renderers in React. That's going to be a light talk. I don't want to get too deep into technical details because it's late. I do want us to have fun and do something a little bit exciting or to bring back the excitement to React. But first of all, I'm very happy to be here in person at this conference. I think it's amazing that during these times, but yeah, that's my picture, but it was like to get us excited again. Personally, being a front-end developer these days because interfaces, which is not and your UI developer, close it and open. That's right. So just a quick reminder for all of us: if I'm going to console log my app component, I'm going to run this function, or I'm going to use JSX and organize a set of utilities that help us to build a tree which contains objects and functions. Which means that I can take this object, I can take React, and I can render it wherever I want. Which means that if you look into React source code, you won't find any piece of code related to the DOM, to the browser. You won't find document create element. You won't even find implementation for.
And that's this stuff I was talking about in the beginning. This type of here.
React hooks. You won't find your state. You won't find your ref. So the React library is very focused, and I describe React as just a set of utilities to build to describe a dynamic tree. Gentle reminder. Cool. So all the heavy lifting of what I'm going to do with this tree happen in the render. Most of the time, we build React applications for the browser. So we just take it like as a fact. We generate project, we got index.js, we use React DOM, we render to the DOM, and we got that. And that's it.
I think I'm just gonna start. I'm just gonna read the source code now. So I think and then I'm gonna search for this stuff here as well to understand how the life cycle of the events work. But I think it's gonna be very hard to find videos about this. So I'm gonna have to search for articles or use ChatGPT and try to study the source code. Yeah. This is the issue, this stuff, is that there's gonna be just videos talking about the basic stuff. So the alternative is just searching for articles or studying the source code.
What is the purpose of a custom React renderers within a DOM host? Prelude. We are all familiar with the default renderers that comes with React, React DOM. We also have custom React renderers that can be used to interface with hosts that aren't the DOM environment, such as mobile devices, famously React Native, VR devices, the terminal, like Ink, and so on. However, there are some custom renderers that operate within, or instead of, React DOM while in a browser host. Core question: what is the purpose of custom renderers that operate within the browser host? Examples. Some notable examples of custom renderers that operate within the browser host are https://github.com/michelachman/react Pixi-viewport, https://github.com/react spring/react3fiber. The following snippet from React 3Fiber 3's elements are declared in React, and under the hood it will map to particular canvas operations. Canvas ambient light greater than point light position equals 10, 10, 10, greater than box position equals -1.2, 0, 0, greater than box position equals 1.2, 0, 0, greater than /canvas. React 3Fiber is using a custom renderer to achieve the above, but I think it could also be achieved with side effects. Box could have a use effect that performs operations against the threes instance. Possibilities, assumptions. So why choose a custom renderer? I believe it may be 0, 1, or more of the following. There is some performance gain by bypassing lifecycle/side effects, tighter control over sequencing and mounting/unmounting, simplicity of code. After the initial hurdle of setting up a custom renderer, the rest of the mappings become easier. Two answers. 2. There are some interesting advantages when it comes to using a custom reconciler in React. As you see in the readme.md file of React Pixi-viewport, it's totally possible to use React DOM to render the Pixi elements instead of using the custom render from React Pixi-viewport. Why create a custom renderer/reconciler then? In this specific case, the reason is that React DOM doesn't really deal with canvas elements. As you said though, they could have been achieved by a combination of custom hooks/components. If you read the Y section of React 3Fiber, you will see that by using their custom reconciler, you can achieve two things compared to custom components. Everything from threads will work here because the support is built into the reconciler. The performance is the same as when using threads directly because the reconciler has more control over what is rendered and when. You can take a look here where there's an in-depth explanation of the difference between render and reconcile and how the reconciler has fine-grained access to components lifecycles, decides the diffing and how elements are added/removed from the view, v and DOM, canvas, iOS, etc. Traditionally, React renderers expose two functions: render children, target, and unmount component node target. React 3Fiber actually exports these two as well, and it could be used like that. But threads in particular needs a lot of setup and boilerplate, which is easier to abstract in a canvas component. That component worries about setting up everything, resize, events, etc. It works in the DOM and in React Native. Everything inside the canvas component is regular React again. You have native elements, mesh, group, components, hooks, etc. So you get the same benefits. That everything from threads will work here because the support is built into the reconciler. The performance is the same as when using threads directly because the reconciler has more control over what is rendered and when. You can take a look here where there's an in-depth explanation of the difference between render and reconcile and how the reconciler has fine-grained access to components lifecycles, decides the diffing and how elements are added/removed from the view, v and DOM, canvas, iOS, etc. Traditionally, React renderers expose two functions: render children, target, and unmount component node target. React 3Fiber actually exports these two as well, and it could be used like that. But threads in particular needs a lot of setup and boilerplate, which is easier to abstract in a canvas component. That component worries about setting up everything, resize, events, etc. It works in the DOM and in React Native. Everything inside the canvas component is regular React again. You have native elements, mesh, group, components, hooks, etc. So you get the same benefits that React offers when you use it on the web or anywhere else. Packing concerns into reusable, self-managed components. I've posted this above. Twitter.com/0ska0a/status/1282999626782650368. This should make it pretty clear why React can always be a suitable choice over imperative layout inflating. Your answer. Building an async React renderer with diffing in web worker. Learnings from tinkering around with React reconciler. This is a mildly edited transcript plus presenter notes of my talk at React Food Deli 2018. I'm trying something new here instead of sharing slides. Let me know which is better. Sync rendering demo. Before we get started, what is asynchronous rendering? Let's take a look at what synchronous rendering looks like. Demo azish.github.io/rrrww/. So here's an example, and what we're going to do is that we're going to try to improve its perceived performance. This is a worst case example, and it might not be related to real world use case, but it will help in understanding the differences in the numbers. So this is how the timeline recording of the sync rendering example. Quick reference, because I'll use this again and again. Blue is HTML and DOM parse. Yellow is JavaScript parse, compile, execution, everything related to scripting. Purple is computing styles and layout. Green is paint and composite. In our demo, first and complete paint happens 6 seconds after page load.end. It paints everything including content which is below the fold. Do you want better first paint? You can use server-side rendering. What will happen in the timeline is the order of the process will change. Purple, layout, and green, paint, will happen before yellow, script. So that will not improve time till the page becomes interactive. When you interact with the page after page load, synchronous rendering makes the website freeze, unresponsive, for 20s. Some browsers may even block scrolling or might even freeze your computer. Other tabs as well. Don't block the main thread. We need to break things up. We want 60 FPS, that is 1000 milliseconds divided by 60. That gives us 16 milliseconds per frame budget. We've heard this time and again. But do we really need to split things up? Chrome, Canary, and thus possibly future versions of Chrome still allow scrolling. This is because the layers have already been painted and translating them does not need to wait for the main thread. Scrolling is a simple composite of already painted layers. CSS transform animations will still run as they are already off the main thread. See this great video by Jake Archibald on compositor threads. Browsers have also been helping us by moving things off the main thread. V8. First move the script parsing off the main thread, and now it has also moved the script compilation off the main thread. This does help us at load time, but does not necessarily help us in interactivity. And sometimes things take time. When the page has a lot of items, /__/. Think about it. People who use your product extensively are going to accumulate.
Right, that's enough about request.
Add lots of elements to the DOM. These are your power users, users who share your product, endorse your product. If your website is not fast for them, they will definitely move on to the next platform. So whatever you do, don't let your website freeze on your users. There are multiple ways, approaches to splitting work on the main thread. Let's check out the one that we're going to build. URL https://azish.github.io/rrrww/async/. For our demo, at load time, the first paint happens earlier at 3.9 s while everything gets painted at 20s. Similarly, at interactivity, you can see things changing without the browser freezing on you, but overall time increases. So it's a trade-off between lowering first paint and overall time. But there is an added advantage of freeing the main thread for any other task that might want to jump in and utilize the main thread. So we are aiming for an improved perception of speed, perception of performance by showing changes in content faster and while not blocking the main thread. Building blocks. I'll give a brief introduction to some of the technologies that we are going to use. Request idle callback, React reconciliation, React Fiber, data structures for DOM. Key takeaways: create your own renderer with React API. Get ready for React's own async renderer. Free the main thread with web workers. Web workers, JavaScript. The language is single-threaded. Platforms provide API to spawn threads through callbacks. Node gives you clusters. Browsers give you web workers. So let's say you have your worker code in worker.jsu. Initialize it from the main thread by passing the path to new worker call. You can send messages to the worker using worker.postMessage. And receive messages by defining the worker.message function. If you want, you can spawn multiple threads of the same worker as well, but we will just stick to one. Similarly, on the worker, you can send and receive messages using focusing on message and post message. Request idle callback. Next up, request idle callback. This is kind of like set timeout, but instead of specifying when the browser should invoke our callback, we give it a loose rein that hey, call me when the main thread is free. You can also specify a timeout, which is max delay. This is kind of like priority, telling the browser, take your time but not longer than 100 milliseconds. The callback function receives a deadline as well. The deadline is currently set to 50 milliseconds and time remaining gives you the time available. After that, the browser won't stop your script or terminate abruptly, but it's just a simple way of helping people write non-blocking code. But before I talk about the reconciler, I want to talk about React 15 and React 16. What changed? You call set state that would trigger React's render process. In React 15, React DOM would traverse the virtual DOM tree, compute the diff and simultaneously patch the diff to the DOM, the light green part. And because we are mutating the DOM, that would trigger layout in paint. Now our aim is to free the main thread, and to do that we need to split things up. So with this approach, React cannot just pause at any time. Can anyone think what can be the problem here? / and it's there in the timeline.if. We split the JavaScript execution as is. If you modify the DOM, layout would get triggered. So instead of layout getting triggered just once at the end of the JS execution, it would keep getting triggered after every pause that you take. Now React has no way of knowing how long layout will take or how to minimize its time. It's a trade-off between freeing up the main thread and repeatedly blocking it with layout. Now what React 16 is doing is that it traverses the DOM, records whatever changes happen, and then applies those changes in one shot. The phase in which it records the changes is called the render phase. The phase in which it applies those changes is called the commit phase. Now because we are not doing anything to the DOM in the render phase, we can now split it up very easily. This is where React is headed in the future release. Plus they are also going to provide hooks in which we can break up the commit phase if we've overused our time budget. I'll get to that later. My async renderer version. But let's go back to now. So while the next version of React is still under development, I wanted to try my hands at async rendering using web workers. So what we are going to do is move the diffing part 1.e, the render phase onto the web worker.and, send what needs to be patched to the main thread using post message. This helps us free the main thread at least when the diff is going on. Then we are also going to split the commit phase as well, naively for now, using time provided by request idle callbacks deadline. Back to React reconciler. So in order to explain the reconciler, we also need to understand what is a renderer. The reconciler handles the vim, compares diffing trees and then sends the changes to the renderer. The renderer actually communicate with the UI layer. Devices can have different renderers while sharing a reconciler. For example, you can have two renderers, one targeting the DOM and another targeting, let's say, the canvas element inside the DOM. The two renderers will consume different browser APIs, but they can share a common reconciler which helps them in determining the diff and what needs to be applied to the DOM. So you write your code using the same familiar React API. You will create your component classes extending React's component, etc. The renderer in this case, React DOM, is a bridge between the reconciler and the DOM API. The reconciler gets your classes and components and creates them for them. The reconciler will tell React DOM that hey, this element was added, this was removed, this property was modified. Now React DOM will look at the property, see if it's an attribute, class, or an event listener, and calls respective DOM functions. React Native. Similarly for React Native, you write almost similar code with slightly different primitives, but essentially the same React API. React Native is the bridge between reconciler and native iOS and Android. Benefits of React renderers. Same declarative API to define UIs, i.e. your UI is a function of your data. Learn once, write anywhere. Renderers in the wild. React Native, React Art, React Tiny DOM, React Canvas, and many more. React Tiny DOM. React Tiny DOM is a very small implementation of React DOM covering only the DOM elements, attributes, and properties, skipping on the synthetic event part. It's only 200 lines of significant code. It's a great place to get started learning how to write a React renderer, and I'll be using its code as example to cover some of the functions. Let's get started. We import reconciler from React reconciler and then pass a host config object to it. This host config is nothing but a collection of callback hooks for when the reconciler wants to pass information to the renderer about changes in the DOM. I'll go over the main callback hooks, while the other ones can be left as no ops. So first we have create instance and create text instance. Here you create instances your UI's low-level component. These functions will be called for each and every element that was created by your components.in. Tiny DOM's case, it is calling document.createElement and document.createTextNode / now to give an illustration. If you had a 3.js renderer, it would create the shape elements here. A D3.js renderer would create SVG elements, etc. Then the append interval child is called. So here you can add your instance to its parent. Your container is your top-level div in which want to render your components. Append child to container is where you add your instances to your top-level container. For a DOM renderer, both append initial child and append child to container are the same, but they might be different for, let's say, a canvas renderer, where your container would be the canvas element, but an append initial child, the parent instance, might be a group. Then finalize initial children is where you apply your props to the DOM element that you just created. Here you go through over each prop, check out its type, if it's style or class name, or if it's an event listener, or if it's a simple HTML attribute. Also, if you need to do something after the element has been committed, you can return true. By committed, I mean when it has been displayed on the screen. For a DOM renderer, a commit would mean it has been added to the DOM tree and a layout has been triggered. So let's say you return true and finalize initial children. The commit mount function will be called after the element has been added to DOM.a. Good example for the use case of this function is that if you need to autofocus on the element after it has been added, you check for the autofocus prop and finalize initial children and then focus on it in the commit mount function. Render phase, create instance, create text instance, append initial child for child nodes of a new tree, finalize initial children. First your elements are created, then they are added to their parents, only if the parents are not part of the DOM tree yet, i.e. the parent elements are also created in the current patch process.and. Then props get added on the elements. Commit phase, append child to container, append initial child, top level node added to DOM. Commit mount, after mount, if finalize initial children return true, then in the commit phase, they are added to the DOM, and if anything needs to be done after they are committed. So to inform reconciler that your renderer supports mutation, you have to set the supports mutation flag to true. Order change. One type of mutation is reordering of elements, and to handle that reconciler gives three hooks: append, insert before, and remove child. One type of mutation is reordering of elements, and to handle that reconciler gives three hooks: append, insert before, and remove child. So we just call the lower level DOM functions here. They are also of the same name. And because this can be at container level as well, we have corresponding container level functions as well. Append child to container, insert in container before, and remove child from container. Properties, attributes change. In the render phase you prepare the diff, create a list of attributes which have changed, and in the commit update function you apply those changes. What you return in prepare update, that is the first parameter you get in commit update. Plug React components. So we saw creation and mutation. Now how to pass our React components to this renderer? So you create a render function which takes the component and a target div, and then you pass the component to the reconciler. Here the render function creates a simple cache on the element if it already has a React tree initiated or not, and calls update container on it. Now let's make it async. So this is a rough diagram of what we're going to build. Our Web worker will send the initial DOM structure. When a user event occurs, we send that event to an action creator which creates an action payload to be sent to the worker. The worker consumes that payload. Here I'm using Redux, so the payload is dispatched as an action which goes to the reducer, changes the store state, and that triggers a re-render. So we saw the host config right. What we are going to do is make two configs, one on the web worker, one on the main thread. The web worker config will be plugged into the reconciler, and when its functions get called, it will create a node of the parameters and will batch these nodes and post message them to the main thread. So this is the object representation of our elements that we will be creating in the web worker. They have type, props, and children, etc. No event handlers for now. But unfortunately, during mutation, when the reconciler provides references of the parent object, we cannot communicate the same to the main thread as the objects are passed by value and every time a new object is created. So we need to assign a unique identification to every object created. End. While sending messages to the client, we reference the elements using this unique id. U/v4 gives us a 16-character long id, and we can namespace them, which can help us in server-side rendering as well. Communicating events is difficult. Here is where we will not be able to plug and play every React component, and hence we'll have to implement some custom logic. So back to our diagram. It's going to be difficult to send the entire event over to the worker from the main thread. So instead, we will define action creators on the main thread, which would get the event. The action creator would extract whatever basic information is needed for the action and send it to the worker by post message. So define a data onClick which defines the action creator that we wish to trigger. We have a global action creators object. It gets the event that was dispatched, and from the event you can extract the target, its attributes, anything needed to create action payload to be sent to the worker. Don't like it myself. Does not scale well. Will not support tree shaking even if you split across multiple files. And this is how you add the event listeners and connect the action creators and the worker. I'm using delegate for event delegation. This is not part of the renderer only because it does not touch the reconciler directly, but can be part of boilerplate needed to use this renderer. Tree traversal. Last step is tree traversal in the main thread during the commit phase. In the commit phase, we have received the DOM object representation from the web worker. If we need to pause this process in the commit phase when we approach the deadline, we need to save the stack position where we paused. Deadline is from the request animation frame we saw earlier. Now this is going to be tedious. If we save the stack position every time before we pause, it's going to take time for us to unwind to the stack position when we resume. And this is also forewarned by Sebastian Markbit from Facebook in this Fiber Principles document, where he says that this generation of stack and rewinding to the place where you stopped might take up a lot of your time of the very small 50 milliseconds budget that we have. Fiber Principles, contributing to Fiber middle. Issue number 7942 middle.facebook/react. I just wanted to document a few unique design patterns that apply to Fiber, but not necessarily anything else. So instead of saving the stack position, we change the way in which we traverse, such that we only need to save at which element we are instead of the entire stack position. This is part of the thought process why React switched from stack reconciliation to Fiber reconciliation. Also, this document is for traversing the DOM for computing the diff, but we are taking those same principles and applying them to the commit phase. Here each node defines where you need to go. First you traverse down to its child. If it does not have any children, you go towards its sibling. If it does not have a sibling, you go towards its parent sibling, and so on and so forth. So now for this new traversal, arrays won't work. So instead of using an array, you use a map for your children. Each child has the unique identifier of itself, its parent, its next sibling, its previous sibling, its first child, its last child. All of these are so that you can do append child, insert before, and remove child in O1. Outcome demo https://azish.github.io/rrrww/async/. Source code https://github.com/azish/rrrww/tree/async_initial. Well, there is a reason why we have not seen these ideas go mainstream. Triple memory required for VIMs. Can't read DOM dimensions. Serialization overhead. State inconsistencies. No prioritization. Commit phase was split by time, not based on priority. So then what? Well, I don't want to look at this as a failure, but as experience gained. And then there's a lot more to look for in the future. Future React versions. Here's what you can expect from the future versions of React. Asynchronous rendering. Prioritization of work. Pull-based approach where React takes decisions for you. Push approach as well where you decide priority. What's pull-based prioritization approach? So React would know what type of mutation has occurred. Here is the list of how React defines the types of side effects. And based on some heuristic, it can decide on its own the priority of which component should it render. Some components might just have callback functions changed probably because they were defined inside the render function, so might not really modify the DOM. And React can deprioritize them over other components. And another example of pull-based prioritization is based on the type of event has occurred. Let's say you want to define the priority of events which are handled and prioritize the side effects caused by these events in the same manner. Your events are also handled by React. You are using onClick, onChange, etc. so it knows which events handler called setState and can track side effects and prioritize them accordingly. Push-based prioritization is where you tell React how to prioritize components. Well, so far we don't know of any API to precisely define numeric priority of components, but there is one way to tell React to prioritize a particular React tree. You can use React.unstable_async mode to wrap your low priority component tree. Other ideas to look forward to. So, in the end, I would also like to reference one great project that is React Native DOM by Vincent Reimer. We took the approach where we moved React DOM to the web worker. His approach is basically take React Native, which is asynchronous by default, and port it to the DOM. Vincent Reimer/React Native DOM, an experimental, comprehensive port of React Native to the worker DOM, open sourced by Google's AMP team recently. Worker DOM duplicates all low-level DOM functions on the worker thread and gives you the ability to move to application to the worker without any complicated setup. They even give you the DOM event transferred over to the web worker thread. So cool. And project/worker DOM, the same DOM API and frameworks you know. So that's the end. I wrote this in a hurry because I kept procrastinating and wanted to get it done with and move on to my next blog. So if you find any errors, suggestions, duplicate text, do write a note and I'll fix it up. Key takeaways: push for async rendering, create your own renderer, free the main thread with web workers. More references: https://engineering.hexac.com/didactfiber incremental reconciliation b2fa028 seek, https://github.com/cobo4/react fiber resources, https://medium.com/agent_hunt/hello world custom react renderer 9A95 b7cd04 bc. More from Aziz Kambadi. Everything JavaScript at Anarok, xhousing.com. Everything JavaScript at Anarok, xhousing.com.
But that's not what I'm doing this time. I'm actually going to take a deep dive into internal browser behavior. In fact, at one point, I'm going to show you how standards are written, right? We are going to be having fun. Like, just set expectations there. I'm not aiming for, at best I'm hoping for, so just set expectations at that, yeah? And because of that, I'm really stressed. I'm stressed that I've ruined Vili's plans for the conference. I'm stressed for you because like, she's going to have to come on stage after this and sort of drag the whole conference out of this heavy technical ditch that I'm about to drive it into, and I'm worried she's run out of the jokes as well. And I don't know, maybe it'll be okay, but I stress a lot. I stress about things that aren't really problems. I stress about things that are really kind of nothing to do with me. A couple of weeks ago, someone posted this picture on Twitter. He's holding a MacBook with 2 fingers above concrete. I haven't slept since I've seen this. I stress about code. I stress about code like this. Firstly, because there's no semicolons. Give me a cheer if you use semicolons in JavaScript. My people, the rest of you are monsters. But that's not the real reason this stresses me out. Because it's adding an element to the DOM, right? And then hiding it. Like, presumably to show it sometime later. And it stresses me out. Like, can we be sure that the user isn't going to see like, a flash of that element before it's hidden? And it's not something I've ever seen happen, but like race conditions, right? You never know. You never know what's going to happen. So I will always just like swap those 2 lines around just so I can get some sleep that night, you know? But in reality, there's no race condition here. The timing of running code versus rendering is all tightly defined and mostly deterministic, and that is thanks to the event loop. If I do a half-decent job in the next like 40-45 minutes, you'll know why these things happen in the order that they do, and I don't know, it might even make sense, but no promises there. So, web pages have something that we tend to call the main thread. This is the main thread. We call it the main thread because a lot of stuff happens here. It's where JavaScript happens, it's where rendering happens, it's where the DOM lives. And this means that bulk of your stuff running on your page has a deterministic order because it's all on the same thread. We don't get multiple bits of code trying to modify the same DOM at the same time, creating all kinds of race conditions. But it does mean that if something on this thread takes a long time, and by a long time I mean like 200 milliseconds, that's a long time for a processor, it becomes really noticeable because it's blocking a load of other stuff from happening. It's blocking rendering, it's blocking interaction. And I think it's difficult for us to empathize with this, because as humans we are extremely multi-threaded, right? I can stand here waving one hand, like standing on one leg, waving the other one, and all the time I am talking, I am taking in visual and audio information, all at the same time. As humans we don't really have a main thread. We don't have things that block unrelated things, but we do have one, and it's when we sneeze. Because as you begin to sneeze, just everything starts shutting down. Like, you lose the ability to talk, that's the first one that goes, you pull a stupid face, that's the second thing. And if you're driving, when this is happening, this is the point where you get to think, I hope no one dies as a result of this, least of all me. The human body that becomes entirely single-threaded, you are sneezing and nothing else. You can't see, hear, think. You can move and make noises, but only in ways that the sneeze wants you to. And then it's over, right? You essentially sort of wake up, and that is when you find out if your car is still on the road, if you still have the same number of limbs that you started with, the same number of passengers that you started with. Needless to say that we don't really want to write code that is like a sneeze. So although we have this main thread, we tend to spawn a whole series of threads for network stuff, for encoding and decoding, for crypto, for monitoring input devices. But once these threads have done something, like interesting, they've got a value, they've got something to report, they need to kind of get their information back onto the main thread. And it's the event loop that orchestrates all of this. So take this, set timeout. It's badly named, yes. The argument's the wrong way around. Possibly, yes, I would agree with that. We haven't thought about how it actually works. Well, let's write a rough web standard for it, because that's what I do for fun these days. Here we go. The set timeout method, when invoked, must run the following steps. Wait ms milliseconds, invoke callback. Done. Excellent. Okay. But spec text runs on the same thread as whatever invokes it, and in this case, it's being invoked by JavaScript. So when we say wait 5,000 milliseconds, we are blocking the main thread for 5,000 milliseconds. This spec is very sneezy. It's not what we want. So instead we do this. We run the following steps in parallel. And this is magic spec text from the HTML spec that essentially says don't block. And the way browsers tend to implement this is they get off whatever thread they're on, which would be the main thread in this case. But we create a new problem. We can't simply invoke a JavaScript callback from another thread, right? Like, else we end up with lots of JavaScript running in parallel on different threads, and that's not what we expect from stuff that's running on the page accessing a single DOM. You'd be in a horrible world of race conditions. So we queue a task to get back onto the main thread at some point. And that ensures that we're calling JavaScript on the thread where JavaScript lives. This is a core part of how the browser works. Like, how does a mouse click event get from the operating system into your JavaScript? Well, it queues a task. When you fetch something, how do you actually get the response, data, the headers and stuff? Well, it queues a task. When you send a message from a page to a worker, how does that work? It queues a task. So the first part of the event loop we're going to look at are task queues. And rather than dive into the spec, because I think we've done enough of that for now, I'm going to try and visualize it. And there it is. That's the event loop, right? I hope this clears up any questions you had. I mean, I do hope it makes sense actually, because I've kind of bet my whole talk on this diagram actually explaining things properly. So yeah, without anything to do, just sort of whiz around in a CPU-efficient manner, of course. Now this visualization is running at a fraction of a percent of real time, and it's still too fast, so we're going to slow things down a bit. When we queue a task, the event loop takes a detour. It goes over here. This is where tasks happen. So at some point, the browser says to the event loop, hey, I've got a job for you, and queues a task on the event loop, and the event loop's like, no problem, mate, sorted, done, and it gets executed, and that's it. But what if we have something like this? We've got these two set timeout callbacks. Well, according to our spec, those two algorithms go parallel, and they're going parallel for 1,000 milliseconds apiece, and then they each queue a task to get back on to the main thread. So, in this model, the browser says to the event loop, hey, I've got something here that wants to do main thread work. Oh, actually, I have two things. This is one for each callback. The event loop is like, sure, just add them separate items to the queue, and I'll execute them in the order that you gave it to me. So there's the first callback, we'll go around the event loop, pick up the second one. Now, there's actually more than one task queue. Specs can define different queues for different things. So here are two queues, both containing 3 tasks. The event loop gets to pick any queue to take a task from each time. The loop guarantees that tasks within a particular queue will happen in order, but it doesn't guarantee which queue an item will be picked from each time. And this is to give the browser some leeway. It means the event loop can give priority to, say, a mouse click event over a set timeout if it wants, because they use different queues. So that's tasks, and it'd be pretty simple on their own, but we're going to take a look at render steps. And this is what the browser uses to update what's on the screen. The render steps are another detour. They're over here. And this is, Emily was talking about this before. This is where computing styles lives, like figuring out which styles apply to which element, creating a render tree and performing layout, figuring out where things will appear on the page and what size they are, then creating pixel data, the actual painting of stuff. Now, at some point, the browser will say to the event loop, we need to update something on the screen. So, can you deal with that? The event loop's like, no problem, I'm on it, and it goes around that part of the loop. Now, I don't know about you, I'm an expert at coding badly. I often end up creating these infinite loops by accident all the time, something I always have to debug. But what actually happens when we do that? Well, let's take a closer look. So if I have a page with a GIF and like some text on it and a big button which runs an infinite JavaScript loop, if I press that button, everything stops. Like, the GIF has stopped updating, I can't select text anymore, it's all locked up. And code for this simple, it is just on click will do while true, that's it. Look, normally when I do this, it's more complicated than that, right? Like, this is just an example. I think I would catch that one in advance. So what's actually happening here? We can show this in terms of the event loop. The user clicks a button, the browser says, hey, event loop, we've got this task for you to do. And the event's like, cool, whatever, I'm on it. But that task never ends. It's running JavaScript forever. And a couple of minutes later, the browser says, hey, event loop, we need to update that GIF on the screen, so can you like render as soon as possible? And the event loop's like, well, yeah, sure, I'll get around to it. Right after I finish this infinite loop, right? I'll be right on it. And then the user tries to highlight text, and that involves things like hit testing, it involves looking up DOM elements. So the browser says, I've got a couple more items for your to-do list there. And the event loop's like, mate, are you taking the piss? Like, do you know how long it takes to perform an infinite loop? There is a clue in the name. It's a long time. So that's why while loop blocks rendering. And it's a good thing in practice. Like, this is the code we looked at earlier. I used to worry that this would result in a flash of content, but it can't because script runs as part of a task, and it must run to completion before the browser can get round to those render steps. The event loop guarantees your task will complete before rendering happens. Still stresses me out, I will still...
Well, I think I saw this a long time ago. It's very good. I think I'm gonna watch this again, and then I'm gonna study the source code. Maybe I'll watch some of those other videos as well to see if there's anything else, because I need to understand more. The main problem with this is that it's just going to talk about the JavaScript and not in the context of React. But I need to understand more how React renders the events to see if I can debug this. So both the events and how is the components related? How are the components that I'm using there from React Pixi related to the events? Because on the viewport, I think is gonna be using events in the context of the React. But then I'm inserting that into the custom component from React Pixi. So I need to understand like how doing that's gonna change the way that the events are handled, I think, to update the state. So I'll be right back.
Flip those lines around though if I see things like that. Here, think you can move and make noises, but only in ways that the sneeze wants you to. And then it's over, right? You essentially sort of wake up, and that is when you find out if your car is still on the road, if you still have the same number of limbs that you started with, the same number of passengers that you started with. Needless to say that we don't really want to write code that is like a sneeze. So although we have this main thread, we tend to spawn a whole series of threads for network stuff, for encoding and decoding, for crypto, for monitoring input devices. But once these threads have done something, like interesting, they've got a value, they've got something to report, they need to kind of get their information back onto the main thread. And it's the event loop that orchestrates all of this. So take this, set timeout. It's badly named, yes. The arguments are the wrong way around. Possibly, yes, I would agree with that. But we ever thought about how it actually works? Well, let's write a rough web standard for it, because that's what I do for fun these days. Here we go. The set timeout method, when invoked, must run following steps. Wait ms milliseconds, invoke callback. Done. Excellent. Okay. But spec text runs on the same thread as whatever invokes it, and in this case, it's being invoked by JavaScript. So when we say wait 5,000 milliseconds, we are blocking the main thread for 5,000 milliseconds. This spec is very sneezy. It's not what we want. So instead, we do this. We run the following steps in parallel. And this is magic spec text from the HTML spec text. It essentially says don't block. And the way browsers tend to implement this is they get off whatever thread they're on, which would be the main thread in this case. But we've created a new problem. We can't simply invoke a JavaScript callback from another thread, right? Like, else we end up with lots of JavaScript running in parallel on different threads, and that's not what we expect from stuff that's running on the page, accessing a single DOM. You'd be in a horrible world of race conditions. So we queue a task to get back onto the main thread at some point. And that ensures that we're calling JavaScript on the thread where JavaScript lives. This is a core part of how the browser works. Like, how does a mouse click event get from the operating system into your JavaScript? Well, it queues a task. When you fetch something, how do you actually get the response data, the headers and stuff? Well, it queues a task. When you send a message from a page to a worker, how does that work? It queues a task. So the first part of the event loop we're going to look at are task queues. And rather than dive into the spec, because I think we've done enough of that for now, I'm going to try and visualize it. And there it is. That's the event loop, right? I hope this clears up any questions you had. I mean, I do hope it makes sense actually, because I kind of bet my whole talk on this diagram actually explaining things properly. So yeah, without anything to do, just sort of whiz around in a CPU-efficient manner, of course. Now this visualization is running at a fraction of a percent of real time, and it's still too fast, so we're going to slow things down a bit. When we queue a task, the event loop takes a detour. It goes over here. This is where tasks happen. So at some point, the browser says to the event loop, hey, I've got a job for you, and queues a task on the event loop, and the event loop's like, no problem, mate, sorted, done, and it gets executed, and that's it. But what if we have something like this? We've got these two set timeout callbacks. Well, according to our spec, those two algorithms go parallel, and they're going parallel for 1,000 milliseconds apiece, and then they each queue a task to get back on to the main thread. So in this model, the browser says to the event loop, hey, I've got something here that wants to do main thread work. Oh, actually, I have two things. This is one for each callback. The event loop is like, sure, just add them separate items to the queue, and I'll execute them in the order that you gave it to me. So there's the first callback, I'll go around the event loop, pick up the second one. Now, there's actually more than one task queue. Specs can define different queues for different things. So here are two queues, both containing 3 tasks. The event loop gets to pick any queue to take a task from each time. The loop guarantees that tasks within a particular queue will happen in order, but it doesn't guarantee which queue an item will be picked from each time. And this is to give the browser some leeway. It means the event loop can give priority to, say, a mouse click event over a set timeout if it wants, because they use different queues. So that's tasks, and it'll be pretty simple on their own, but we're going to take a look at the render steps. And this is what the browser uses to update what's on the screen. The render steps are another detour. They're over here, and this is, Emily was talking about this before. This is where computing styles lives, like figuring out which styles apply to which element, creating a render tree and performing layout, figuring out where things will appear on the page and what size they are, then creating pixel data, the actual painting of stuff. Now, at some point, the browser will say to the event loop, we need to update something on the screen, so can you deal with that? The event loop's like, no problem, I'm on it, and it goes around that part of the loop. Now, I don't know about you, but I'm an expert at coding badly. I often end up creating these infinite loops by accident all the time, something I always have to debug. But what actually happens when we do that? Well, let's take a closer look. So if I have a page with a GIF and like some text on it and a big button which runs an infinite JavaScript loop, if I press that button, everything stops. Like the GIF has stopped updating, I can't select text anymore, it's all locked up. And the code is simple, it is just on click, will do while true, that's it. Look, normally when I do this, it's more complicated than that, right? Like, this is just an example. I think I would catch that one in advance. So what's actually happening here? We can show this in terms of the event loop. The user clicks a button, the browser says, hey, event loop, I've got this task for you to do. And the event's like, cool, whatever, I'm on it. But that task never ends. It's running JavaScript forever. And a couple of minutes later, the browser says, hey, event loop, we need to update that GIF on screen, so can you like render as soon as possible? And the event loop's like, well, yeah, sure, I'll get around to it. Right after I finish this infinite loop, right? I'll be right on it. And then the user tries to highlight text, and that involves things like hit testing, it involves looking up DOM elements. So the browser says, I've got a couple more items for your to-do list there. And the event loop's like, mate, are you taking the piss? Like, do you know how long it takes to perform an infinite loop? There is a clue in the name. It's a long time. So that's why while loop blocks rendering. And it's a good thing in practice. Like, this is the code we looked at earlier. I used to worry that this would result in a flash of content, but it can't because script runs as part of a task, and it must run to completion before the browser can get round to those render steps. The event loop guarantees your task will complete before rendering happens. Still stresses me out, I will still flip those lines around though if I see things like that. So while loop blocks rendering, but what about this? So this is a function that calls itself, but via set timeout, something that queues tasks. Well, let's find out. Same example again. Click the button, and nothing appears to have happened. Everything's still working. But something has happened. So let's run that loop. So the browser's like, got a task for you, the event loop's fine, whatever, I'll run that. But part of that task, it queues another task. It's like, okay, right, so we'll go around and run the next task, no problem. On and on until, the end of time itself. But as we've already seen, only one task can be processed at a time. It has to go all the way around the loop to process the next item. And that means that the browser says, oh, we should update the display. The event loop's like, fine, I'll do that. And there it goes. And this is why a set timeout loop isn't render blocking. But if you want to run code that has anything to do with rendering, a task is really the wrong place to do it. It's like tasks are kind of on the other side of the world to rendering according to the event loop. What we want to do is we want to run code in the render steps themselves, around about here. And the browser gives us a way to do that. And this is using request animation frame, another badly named function. You're welcome. Wrap callbacks, they always happen as part of the render steps. So to show why this is useful, let's animate a box, just a box. Here's the code. I'm going to move that box forward 1 pixel, then request animation frame. I'll do it again, and again, and again. And there it goes. Yeah, thank you. Excellent. Request animation frame, ladies and gentlemen, right. But what if we did the same thing, but instead of request animation frame, we use set timeout? Well, that's different. It looks like this. The box is moving faster, around about 3.5 times faster, I'd say. That means the callback is being called more often, and that is not a good thing. We saw earlier that rendering can happen between tasks. So here we go, task, and we'll go and render, fine. But just because it can does not mean it must. So in reality, the event loop can do a task and go, shall I render? No, I can't be bothered. So go and pick up another task. Right, should we render this time? Nah, maybe next time, off we go. Many tasks can be executed before the browser goes, yeah, okay, we'll render and update the display. Now the browser gets to decide when to render. It tries to be as efficient as possible. The render steps only happen if there's something to update. If nothing's changed, it won't bother. If the browser tab isn't visible, it won't bother. But also the majority of screens update at a set frequency. As Emily was talking about this earlier, it's mostly 60 times a second, and that's why 60 frames a second is our goal. But some screens run faster, some screens run slower. This screen runs at 30 hertz, so like 30 frames a second is the target because it's as fast as it can do. But 60 hertz is the most common. If we change the page styles like 1,000 times a second, it's not going to render 1,000 times a second. It's going to synchronize itself with the display and only render up to a frequency that the display is capable of, and usually 6 times a second. And that makes sense because otherwise it would be a waste of time. There's no point in rendering things the user will never see. But that is what set timeout is doing here. The box is moving faster because it's updating the position of that box more times than the user will see, more times than this display is capable of displaying. And also, so far we've been using this like, set timeout thing to kind of mean queue a task. It's not that pure, unfortunately. It's still, even though we're saying 0 milliseconds, it still waits a bit. It seems to be around about 4.7 seconds, but according to the spec, browsers can pick any number they want to sort of round up to. That just seems to be what Chrome and Firefox and Safari do. There isn't just a simple method to queue a task. I guess set immediate was sort of that, but don't have that. But you can sort of emulate it using like message channels. If you create a message channel and post from one channel to the other, it always uses a task to do that. So that's the closest thing to queuing a task. And if we use that, and if you're sensitive to flashing images, you might want to look away now because that looks like this. Tasks are happening so frequently, it looks like the box is just getting a random position. We're getting a task every 200th of a millisecond on this machine. So rendering can happen between tasks. We've seen that. But you have many, even thousands of tasks between renderings. Okay, flashing images are gone now. Right, imagine each of these is a frame that gets displayed to the user. The render steps happen right at the start of the frame, like, and that's style calculation, layout, and paint. I like this. It's very neat and tidy. I like it. Tasks, on the other hand, couldn't give a shit. They're just higgledy-piggledy all over the place. The event loop does, it guarantees order of things within a particular task queue, but in terms of the timing within a frame, they do not care. And we saw this with set timeout before, right? Like we're getting 4 of these per frame, 3 or 4 of these per frame, meaning 3/4 of them wasted effort in terms of rendering. Now, some old animation libraries used to do this, so they're calling set timeout, and this number here is like 16.7 milliseconds roughly. So the aim is to try and do that 60 times a second. It's assuming the screen is 60 hertz, but like I said, that's true in most cases. So that eliminates some of the duplicate work, fine. But it is a total hack. Set timeout wasn't designed for animation, and it does show, so due to inaccuracies, you end up with drift, where like in this situation we've missed a frame, and we've done twice as much work in the frame after, which is pointless, and that causes visual jank. Also, if one of your tasks runs long, it can end up sort of getting in the way of the render steps as well, like spoiling their lovely routine, which is very rude. If we use request animation frame, this will look a lot more like this. So everything all nice and ordered and neat and tidy, and I like it. Even this expensive bit of JavaScript over here is well within the timing of a frame. I like seeing performance traces like this. Makes me feel nice and calm. Of course, you cannot avoid tasks completely. Most events are delivered in tasks, not all, but most of them. So if you click somewhere, you kind of want to act on that straight away, and that'll be in a task. But if you have things like timers, if you have things like things running from the network, it's worth using request animation frame to sort of schedule and debounce that stuff to batch it together. Especially if you already have animations running, and this will kind of save you a lot of CPU time. I treat tasks like I treat people who drink fizzy water. I acknowledge that they exist, but I do not trust them. Like, I would consider myself a person like quite empathetic, maybe. I don't know, but I do have my limits. I think soda water is vile, and I believe it's impossible for a human to drink it without gagging and throwing up. So the people who do drink it, something else is going on there. I maintain a Twitter list of people who drink soda water. It's not a creepy thing. I'm just keeping my eye on them. But when I find the link between these people and Brexit and Donald Trump, I am blowing the case wide open. There's a link. There's got to be. And it pains me to tell you this, Smashing Conf, but this conspiracy goes straight to the top. Yeah, also watch out for that guy. Where is he? Plotting. Every now and then some smart ass will say to me, but Jake, you drink Diet Coke. I think you'll find the main ingredient of that is fizzy water. No, that's different. Completely different. The main ingredient of air is nitrogen, right? But let's see how long you last breathing just that. Totally different. Anyway, that's request animation frame. Actually, before we move on, there's one detail that catches most developers out, and it's caught me out as well. Request animation frame happens before processing CSS and before painting. So code like this might seem expensive, like looks like we're doing loads of stuff, but as we saw earlier, like JavaScript will always run to completion before rendering happens. So in this case, the browser just sits back and lets you have your fun changing one value back and forward. It doesn't really think about the result of any of this until the style computation parts of the render steps, and that's when it goes, all right, what did you actually do there? And the only bit that matters is this last line. Cool. I need to explain the gotcha in CSS, something like I certainly ran into, you might run into as well. I had a thing on a page, and when I use a click to button, I wanted to animate that thing from an X position of 1,000 to 500. Sounds like it should be easy, but it's the web. So I had my listener, and I set the transform to 1,000, start position, fine. Set a transition, because I want to transition it, and then I changed the value to 500. But that animated from 0 to 500. I'm like, no, Mr. Browser, that is not what I asked you to do. I clearly said 1,000 to 500, and not 0 to 500. But the reason is the same, right? It's setting these things, and it's just sitting back and letting me set values over and over again and ignoring me. So the first value where I set 1,000, it effectively ignores it. The start position is overwritten before the browser thinks about styles. Anyway, I figured that out, and I thought, right, we'll fix that. And I wrapped the second bit in request animation frame, and there we go. And now, it still animates from 0 to 500. It's still broken. What is going on? I will tell you what is going on, so I figured it out after reading the spec. So the user clicks on the button. So, we'll queue the task. Fine. Then loop comes around, starts running that task. And this is where we set that initial transform and then the transition. And then we queue a request animation frame, so around we go. And this is where we set the final position. But the browser doesn't think about styles until the block that comes next, the purple block of the S in. That's where it calculates style changes. So again, just like the previous example, it's losing that first value before it ever thinks about it. And that's why you need not one, but two request animation frames if you want that thing to correctly animate from 1,000 to 500. This ensures the browser calculates the style of the start position, and then later calculates the end position in two separate style calculations. There is a hacky alternative to this. We can use getComputeStyle and read the transform property. And this forces the browser to perform a style calculation a lot earlier than it naturally should, but it makes it take note of that start position, and this works fine. But like Emily said before, you need to be careful if you're forcing the browser to do these things earlier than it naturally would. This isn't layout thrashing as such, because by accessing getComputeStyle, we're only asking it to compute styles, not layouts. So it's a little bit cheaper than that, but you can still run into the same problems. The correct answer, the easiest way to actually do this would be the web animation API, but it's only in Chrome, so yeah, whatever. It's not a great answer for real world yet. So if that was a surprise to you, this positioning of request animation frame, do not feel bad because Edge and Safari get the part of the event loop very wrong. They process RAF like here, in the wrong place. And that means when you get a click event or whatever, or something in a task, and you queue an animation callback to change some stuff, Edge and Safari will update the display before running your callback. So if you're trying to make rendering changes, the user will not see them until the frame after that one, and it's reasonably significant delay depending on the screen. It's a real pain in the ass when it comes to trying to defer stuff to the rendering steps, because it's going to put the extra frame in the middle that you don't really want. So that's Edge and Safari. I hope it's something they fix soon. Chrome and Firefox, they do it in the right place according to the spec. Right, that's enough about request animation frame, but I wanted to address a little bit of a lie that I told earlier in the talk. We're going to have a look at the compositor. You see, earlier I said that an infinite loop blocks rendering, and that is kind of true. But here's another example, very similar to the one before, but there's a little bit of extra movement in that GIF. I click the button, the GIF stops, I can't interact with the page, but it's still doing that little animation. What's going on? Something non-standard is going on, but it is something all browsers do, so probably something we should look at standardizing. Although the render steps are in charge of style calculation, layout, and paint, it isn't the thing that actually puts the pixels on the screen. That is down to this. This is the compositor thread. It is also syncs to the display, like the render steps are, so it'll kind of run at 60 Hz on that kind of screen. Let's take a closer look. So, when the browser comes around to do some painting, and this is where it creates all of the pixel data, but like I say, it doesn't put that straight on the display, it actually uploads that to the composite thread as a texture, and there it goes. And the composite takes all the pixel data it receives, and it arranges them into a page, and that's what gets outputted. And this is where things like scroll position are taken into account. So it's got all the textures, and it goes, oh, but the scroll position's at 50, so I'll slide that stuff up by 50 pixels, and that's how that works. But in particular situations, it can do something pretty cool. Like if during style calculation here, it sees a declarative animation, by which I mean a CSS animation, CSS transition, or a web animation API animation. Basically any kind of animation where it knows start and end in advance. It can look at it and go, this whole thing can just be done on the compositor. So it uploads a program to the compositor, and off we go. It can control the rest of the animation. And it only works if it's the kind of animation that the compositor can handle on its own. The compositor, once again, like Emily was saying, it can't draw. It can only take already drawn bitmaps and move them around. But that works in this particular situation. Like instead of drawing this as just one image, it draws it as two, and now it can move those things around independently. Not just position, they can be rotated, like even in 3D. It can also change opacity, like perform particular filter event effects, some of the mixed blend mode stuff. That can be done here. Certain kinds of clipping as well. It's something Safari's really good at, and I wish your browsers were as good as Safari in that respect. So what browsers can do on the compositor is a little bit different per browser, but like opacity and transform filter as well, I think are pretty common across all the browsers. Anyway, we didn't do anything in 3D. We just did a little rotation on that image, and yes, all of that can be done on the compositor. So when the user clicks that button, we queue a task, and yes, it contains an infinite loop. So the event loop is blocked. It can't update the frame of that GIF anymore because that's a paint action. It needs to upload the next frame. It can't handle user interaction because that involves the DOM, and that's all blocked. But the compositor keeps on spinning, and it has the program for doing that little rotation animation, so that's why it can continue. yeah, so that's why particular animations aren't blocked by JavaScript. And it's certainly something we recommend that if you're using things like transform, you use transform rather than top and left because that can be uploaded to the compositor and it won't be janked by things running on the main event loop. Okay, that's enough about rendering for now. It is time to have a look at microtasks. Probably the least understood part of the event loop, I'd say. I pretty strongly associate microtasks with promises, but that is not where they started. Back in the 1990s, browsers wanted to give developers a way to monitor the DOM, monitor changes in the DOM. So W3C gave us mutation events. And this meant you could add a listener for something like this, like for when a node was inserted, among other things. But in practice, this is really problematic. Say we're going to add 100 spans to the body of the page like this. How many events would you expect from this? Like 1 event for the whole operation? 100, 1 for each span, yes. But also another 100, 1 for each text node being inserted into each span. And that's because these events bubble. Because of this, like relatively simple DOM modifications could trigger thousands of events. And if developers say we're doing some work in those listeners, it quickly became a whole bunch of work and it became a real performance disaster. What we really needed is some way to have these things patched up and just be told about kind of sort of independent changes. And we've seen already the browser does this with style, like we were able to change those values, the browser just sat back and kind of paid attention to the overall change. We need something similar here, because this is just one piece of work. We only want 1 event, not 200. The answer became mutation observers rather than mutation listeners, and they created a new queue called the microtask queue. Most documentation I read about microtasks say it happens at the end of a task or at a turn of the event loop, which doesn't really mean anything. And it's kind of true. There is a point on here where the microtasks are handled. It is just after a task, but that is not where you're likely to encounter them. Microtasks also happen when the JavaScript stack goes from being not empty to empty. So it's kind of whenever JavaScript finishes executing. So you can end up like running microtasks within a task. You can end up running them within the render steps as part of a request animation frame or other events. Anyway, JavaScript can run. So that means that this JavaScript runs to completion, 100 spans and their content are added, and then once JavaScript's finished executing, it goes, some stuff has changed in the DOM, I will fire an event to deal with that. So promises, they also use microtasks. So here, a microtask is queued, fine, and then we log yo, and now the script is done. JavaScript stack has emptied, so we process those microtasks, and there we go, we call our promise callback and log hey. That means that when a promise callback is executing, you're guaranteed that no other JavaScript is halfway through executing, and that's one of the important reasons microtasks were used. You're kind of guaranteed the promise callback is at the very bottom of the JavaScript stack. What happens if we create a microtask loop? We saw this with set timeout, we've done all JavaScript. What about microtasks? Well, same test as before, click the button, whole page freezes. It blocks rendering just the same as a while loop does. So sure, promise callbacks, they're async. Well, but what does async actually mean, right? All it means is that it's going to happen after synchronously executing code. So in this case, yo is logged before hey. That makes it async. It doesn't mean it must yield to rendering or any other part of the event loop in particular. We've looked at 3 different queues so far. Task queues, animation callback queue, that's the request animation frame, and now microtask queues. And just to make your lives fun, they each empty in a slightly different way. Okay, so like we've already seen, when it comes to tasks, we get to the task part of the event loop, and we process 1 item, and only 1 item. And if we queue another task as part of that, it goes to the end of the queue. Done. When we process animation callbacks, we process them all, except ones that were queued while we were processing animation callbacks. And otherwise animation wouldn't work. If you call request animation frame inside request animation frame, that should happen in the next frame. Microtasks, on the other hand, they are processed until completion, including any additional items that are added. So if you're adding items to the microtask queue as quickly as you're processing them, you are processing microtasks forever. The event loop can't continue until that queue has fully emptied. And that's why it blocks rendering. I get really excited about this stuff. Sorry if everyone's bored. I'm really excited about this. Like, I used to have a proper job. Like, I really did. Like this stuff, like the standard stuff, the open source conference speaking, this used to be my hobby. But then my hobby became my job, and now I have no hobbies. I'm a boring person. So I didn't actually notice this happening, you know? I didn't notice until I went for a night test, where I live in Hayward. And the optician, just making small talk, just asked, what are your hobbies? Oh, shit. When did this happen? I can't say nothing. And I panicked, right? And I shit you not, I said, I play the piano. I don't play the piano! And I was really stressed that she was going to say, well, that's great. We don't need the letter chart then. Here's some sheet music. Then you read the first 5 bars. What chord is this? Thankfully she didn't. But I'm terrified to go to my opticians now in case we strike up some musician chat that I couldn't be part of. I don't know how I survive outside sometimes. Right, okay, I think you're ready for this next one. I occasionally run little JavaScript quizzes. Maybe that's my hobby. Nope, that's work too. Fuck, okay. Anyway, this is one of my favorite questions. We've got an event listener, and we've got a queue and microtask, and just do a normal console log. But we have another listener on the same element doing the same thing. If the user clicks a button, what happens? Which order are those things logged? Well, our first listener executes, and that queues a microtask. Fine, okay. And then we go on to log listener 1. Done, okay. So that's our first answer. And most folks agree on this bit, but what next? A couple of weeks ago I actually ran a Twitter poll on this. 63% of people say that the next thing that will be logged is listener 2. 5% of people think nan is logged 3 times and then infinity. That's not the answer, but fair enough. But as you can see, thinking listener 2 is the common answer, it's the wrong answer. But if you thought that as well, then you're in very good company, that's what most people think. But no, because our listener has finished. We've gone from having something on the JavaScript stack to nothing on the JavaScript stack. So that means it is microtask time. So we go straight to the microtask and we log microtask 1. And then we do the same for the second listener, right? And that works the same. So the order is listener 1, microtask 1, listener 2, microtask 2. But that is only if the user clicks the button. What if the button is clicked using JavaScript? Oh yes, it is different. Very different. For starters, like our script is on the stack, right? Script's on the stack and we call click. And that synchronously dispatches the event. Button.click or button.dispatch events, they work exactly the same. Anyway, and that means we're going to start with our first listener, so that's on the stack as well. We queue a microtask, excellent. We log listener 1, fine. And now it's microtask time. No, it is not microtask time because our JavaScript stack is not empty. Event listers run synchronously. Our call to button.click has not yet returned. So no microtasks. We go on to the next listener, queue another microtask, and we log listener 2. And now our listener is done. In fact, all of our listeners are done. So button.click returns, and now our JavaScript stack is emptied, and now we can process those 2 microtasks, and they happen in order. So that small little difference has kind of changed the order. It's changed when promises run. And this has real-world practical implications. If you're using automated test frameworks, be careful if they're using JavaScript to click on things, because you'll start getting these differences showing up. And like I said, the same happens with manually dispatching events. So look for an automated test system that dispatches clicks at the operating system level, or uses something like Chrome DevTools protocol, so Puppeteer and all that sort of stuff. They do the right thing here. They're doing real clicks. They don't have this problem. But no practical place where this came up is we're looking at how to add observables to the DOM. It's something we're still looking at. We're also looking at how to integrate with promises. And we hit this question. So this is a promise for the next click on a particular element. So it's just a little bit of code. New promise, add event listener, click, and we'll resolve then. Fine. But the question we had is, can someone still call event.prevent default when they use this promise? Because promises are async, right? Have we missed our chance to prevent the default? Turns out, no, it's fine, it works, not a problem. Unless, as before, the event is triggered with JavaScript and then it changes. And to figure this out, we really kind of need to look at the spec. This is a little bit simpler than the real spec, but it shows the problem. So this is what happens when a link is clicked. We create an event object, and then for each of our listeners of type click, we're going to invoke the callback with the event object. Fine. And then if event object's cancel flag is unset, we're going to follow the hyperlink. When you call event.prevent it sets the cancel flag on the event object. That's how that works. So if you click the link, this is fine. Our microtasks happen right here after every callback. And that's before step 3. So if they call prevent default, that's fine. We'll pick that up and we won't follow the hyperlink. If we call click with JavaScript or dispatch event, it's just going to call straight to our other algorithm here. But the JavaScript stack is no longer empty because that click method is synchronous. It's going to stay on the stack throughout the whole process. So we can't run those microtasks there anymore. They run much later, sometime after click returns. And that means step 3 is going to happen before any of our microtasks run, so the hyperlink is followed. And then sometime way later, our promise callbacks happen, and we try to call prevent default, and it just doesn't do anything. We've already followed the link by that point. So if you're trying to turn something synchronous to something asynchronous, do bear this in mind. Remember that microtasks only run when the JavaScript stack is empty. Right. Okay. Last thing I want to talk about. I want to talk about event loops. Now, some of you might be thinking, what exactly has he been talking about for the past 40 minutes, if not exactly that? Well, I've been talking about an event loop. But in reality, modern browsers have many, all doing their own independent thing. For instance, if you create any kind of worker, it gets its own event loop. That's how it doesn't jank the page. The browser UI usually runs on its own event loop. What about multiple pages? You've got multiple tabs, multiple pages going on, iframes and stuff. Like, what do they do in terms of event loops? Well, naturally, there's no straightforward answer here. All browsers used to put all pages on the same event loop, including the browser UI itself. So here's an old version of Firefox showing 2 pages from completely different sites. And I click the wild true button, and both pages are locked up. In fact, the whole browser is locked up. I can't interact with any URI or the buttons or the URL bar or anything like that. While I'm clicking around there, it's just adding things onto the task queue, the event loop. What Firefox would do is eventually it would halt long-running scripts, and then that queue would start emptying again, so this would happen, like everything starts moving and reacting to all those clicks. When Chrome was released, it was the first browser to put tabs on different processes, therefore different event loops. So here's Chrome, click the button, that page freezes, fair enough, the other page still keeps on trucking, and the browser UI, that all works, not broken or anything. That was Chrome 1. Internet Explorer 8 kind of did it in some cases, Edge does a much better job. Safari 7 introduced the same thing, and Firefox was kind of late coming here. It introduced it just in November in Firefox 57. But the extent to how browsers do this, it varies. The only rule in the spec is that pages must share an event loop if they gain synchronous access to each other, or if they can gain synchronous access to each other. What does that actually mean? So here's 2 iframes. One is same origin, one is cross origin. With the same origin iframe, I can get access to its window, its document. I can add stuff to the DOM. I can read stuff, call JavaScript. I can really do whatever I want. And this means the iframe must be on the same event loop as the parent. Otherwise, there'd be no way to do that kind of synchronous communication between the two. It would be just race conditions everywhere. If I try and access the content of the other iframe, I get a big error. Right, it doesn't work because I shouldn't be able to read and modify the contents of your bank. This means this iframe can have its own event loop. Though browsers are actually very good at doing that for iframes. It's something we're working on in Chrome. It's behind the flag. We're just fixing the final bugs around printing. Turns out. Same goes for window.open. Window.open works pretty much the same as iframes. But what if we have a link like this with target blank, so it's going to open a new tab? Will the newly open page get its own event loop? Well, let's test it. So I'm going to click the link here, opens a new tab as expected. I'm going to click that button. Now this has locked up both pages. So in this case, they are on the same event loop. And it has to do this according to the spec. Now, when you open a page this way, your page doesn't get access to the page it opened. There's no way to do that. But the new page does have access to the parent using window.opener. And that represents the window that opened this one. And because the 2 pages are on the same origin, the child can synchronously access the parent and do whatever it wants. The same as iframes before. What about this case? Same URL, roughly the same link. Click the button. This time it only locks itself up. It doesn't affect the other page. The parent page continues to work. The only difference in that second case is that link use rel equals no opener. And that means that opener is null on the other page. There's no way for the 2 pages to get synchronous scripting access to each other, so they don't need to be on the same event loop, and that's why one page doesn't disrupt the other. And it's optional for browsers to do that, but it's something that Chrome and Edge do. It will sometimes work in Firefox. Firefox will have a maximum of 4 event loops for pages, and it just kind of distributes them evenly. That's kind of a way that they save memory. We prefer to try and use a different event loop as much as possible to keep us kind of security isolation reasons. In Safari, it doesn't make a difference, it'll still look up the page, but it's an optimization they can make. That said, it is important to use no opener even for cross-origin sites. Like if you're linking to another origin, it can't do this because it's another origin, right? It can't start messing around with the page, but it can write to the location object and navigate the parent page. And this will change the URL bar of the page and everything. It'll do a full navigation. But if the user clicked on the link and they've opened a new page and they've gone around and that page has secretly navigated the parent page to a different URL, but it looks the same as your bank or whatever, can you be sure that the user will catch that? Can you be sure they'll realize that that page can navigate the other one? And that's why we recommend using no opener on all external links, especially if they open a new window. Okay, that was a massive brain dump. Pretty much everything I know about the event loop, about all the various steps and various queues that there are. Knowing this stuff, going through the spec on this has really reduced the number of times I need to throw a set timeout around like something just to kind of fix a bug, and even then only fix it intermittently. It's helped me avoid jank by getting stuff kind of running only once per frame rather than multiple times per frame. And I hope I've managed to explain it in a way that was useful to you too. Like I said, I'm a stressful person, so I'm going to go and collapse somewhere now. But you've been a great audience. I've really enjoyed this conference. Thanks to all the speakers. Thank you very much.
I'm sorry to be the bearer of bad news, but you can't collapse yet.
This image is also really interesting to see. It's like a multifractal pattern. And it's interesting to think about that. The DOM is just a tree, which is also a multifractal pattern, which is a hierarchy. The whole pyramid fractal thing that the other presentation shows. So like, it's constantly the tree pattern, fractal pattern becoming this one, and vice versa. So I think it's interconnected. It's like the way gravity becomes information. It happens in cycles and then creates a multifractal hierarchy that changes the state of the informational field in relationship to a reference frame. So like inside of the fractal, that is the dome tree, you have the cycles, which is the gravitational force of the page, let's say. I think there must be obviously correlations between this and physics because it's the same thing. It's just computation, so it's interesting to think about.
I'm sorry to be the bearer of bad news, but you can't collapse yet.
Oh,
Join me in the chair.
I tried to
Of
run long,
doom.
so I avoided this.
I'm just going to ask some really light questions.
All right,
Sorry I'm
all
a
right.
little late, and I was so mesmerized by your slides that I just didn't even
Taking any
think
information. That's what I was aiming for, yeah.
They were so good. How did you make the slides? How long did they take you?
It was a couple of weeks of tinkering and stuff.
Okay.
Yeah, it was time. It was time. I
Yeah.
was enjoying myself. It was the first time I've kind of done a lot of manual stuff with SVG and stuff. So that
Very
was really
cool.
fun. It was
And what Jake didn't mention is that last slide with all the circles, which kind of remained throughout, was generated in random circles. Can you talk about that more? It's really cool.
Yeah, the code is terrible. It's one of those things like, oh, I've got to give a talk. I probably shouldn't spend 3 days trying to get one animation, like unimportant animation working. Yeah, it was just an SVG circle with a little dot on it. And it was just, but it was animating the SVG element itself because that goes onto the composite thread. So it would just pick random places to see where it would grow the circle until it touched another circle or reached the maximum size. And then they just kept doing that until it was like a minimum size of it. If the circle couldn't get beyond a certain size, it didn't bother. And then when it tried to place 100 circles and didn't manage that 100 times in a row, it would just stop. And that was it. So it's terrible.
It looked nice while we saw it.
Yeah, lots of main thread for 200 milliseconds. But the great thing is, the end of the previous slide is normally static, so you don't notice. It's great. Yeah, it's cheating.
Yeah,
Fantastic.
speaking of bad performance. So you showed the slide with all of these different animation loops on a page.
Yeah.
That probably would be the best thing, right? In Firefox, I can only have 4 max. So what would you
Yes.
recommend to make this a more performant experience?
For what particular kind of animation? What for like?
Using animation loops or multiple animation loops on a page.
It should be fine. Like the thing to avoid is having layout thrashing. Like if you're avoiding layout thrashing, you're doing the best thing. Yeah, because you need those multiple callbacks. There's not a whole lot of benefit of merging those multiple callbacks into one, unless it's to avoid layout thrashing. That's, I kind of wish that we had a system where we had a callback for after render. I've got a thing in the HTML GitHub thing to kind of say like we have a callback just right after paint. So we have one place where we do all the reads. Like I've thrown all the styles at the thing. It's rendered. Now give me a point where I can kind of read the position of everything ready for the next frame, and having that sort of regimented way of doing that will hopefully prevent like layout thrashing.
Totally. Have you seen any really good examples of web animation in the wild lately that use some of these techniques, like maybe microtasks, something else that you brought up?
I mean, using mixing animation and microtasks wouldn't be usual. I mean, there's the web animation API has promises built into it, so you're kind of using microtasks there by default. The only case you would really use microtasks is if you're wanting to batch work together. So I know React uses microtasks, so that if you update state multiple times, it doesn't update rendering multiple times. It uses a microtask to let you sort of finish your work and then end it. That's not animation specific. No, so I guess my answer is no.
Okay, so that's interesting to note that React uses microtasks. The last question is just a really general one. Is what are you most excited about these days? Like, what's new, shiny, and wonderful in the web for web performance or web animation?
For web animation, it's the animation worklet. So this is a way that you can run some degree of code on the composite thread. So like that sort of, with CS animation, you can do like a bit of a rotation or something. But if you wanted to link animation to like the scroll position or do some more complicated stuff, like if you're doing animation that you wanted to sort of do a bounce effect, there isn't a way to do that using like the cubic Bezier easing stuff. So yeah, this worklet that will run the composite thread will be a way of doing that. So that, one of the examples we have is like when you're scrolling on Twitter and the avatar sort of gets smaller and then sort of locks to the top, you can do that there, and you're not running that on the main page, so it's out of the way of a JavaScript that's running. I think we're getting close to a spec on that. It was so the Chrome team kind of wanted to just let people do JavaScripts, any JavaScript they want on the compositor. The Safari team were like, no, we don't want that. We want just like some kind of declarative CSS thing. So it's kind of been a meeting in the middle where it's sort of partly declarative, partly imperative. A lot of stuff set up in advance, like the timings and stuff, but per frame you can decide the position of particular textures that are being composited.
Okay.
So I'm excited about that.
Yeah, so is there a timeline for it? Is it still in early stages?
Oh, now you see, it's not the thing I work on, so not my department, mate.
Yeah, not my problem.
If we haven't got something in Canary already, we've got Paint worklet is in Canary now, or it might even be heading towards stable. Animation worklet, I think we've got stuff in Canary, but I don't think it's not ready for prime time yet.
Yeah.
They're still figuring out parts of the spec.
So just look out for it.
Yeah, maybe this year, maybe, I don't know.
Yeah, cool. Thank you so much. That was an amazing talk. Give it up for Jake one more time.
Thank you very much.
Cheers.
Yeah, it's a very good talk. For my thing, not sure if it's like clarifies a little bit more. I'm pretty sure I've seen this talk before as well, but it's still because there's a lot of more things involved. I think the problem is that I don't know how React handles that. The event listeners, I'm pretty sure it's similar, but there might be differences in the way that the state is related to the callbacks and the loops he was explaining with the microtasks and the differences between them. Difference between microtask, the task, and the other one in the middle that I forgot. I think is queue. And how the flow of the execution is gonna happen there based on them. So, but it might be different. Yeah, the thing is that he doesn't say, obviously because the talk is not related to React, but how React handles the event loops. That's the thing. So I think for my thing, I need to understand first. I think I'm gonna start studying based on the stuff that is important first. I think that's better than just reading the file there. So I think I'm gonna start by studying this Pixi component. So I think that this is part of the main problem, but the thing is that the stage is created through the React Pixi as well. So maybe it's not related to the rendering thing, but the thing is that the viewport, because it's a separate class, but it is created here. So like I think that the main thing is the way that the React Pixie is gonna create these components and the way that the event listener works. So it's both how does event listener works on React and how does Pixie create the event listeners. But I think that's maybe I should try to implement an event listener on one of the components to see like if it is gonna fail as well or if it works fine. Because I think the only thing that I'm doing here is using state, and I haven't tried to add event listeners to the components. It's just using the hook for now to change the animations. But I guess the engine has the event listeners though. It should be implemented inside of this because you can click and drag the nodes. But maybe it's just because of the use stick actually. Yeah, but it should be an event either way. So it probably comes from the Matter.js engine. It comes with the events, maybe. Oh, maybe actually is the use ref of the bodies, I think. Is the use ref and the use tick. Because when you click, it updates. I'm not sure. Oh, it is the mouse that enables the event listers, maybe? I think I'm gonna read the documentation again. I think it's difficult because there's so many things involved with this problem. Well, the mouse comes from the Matter.js. Yeah, that's the thing that creates the inputs. So it's interesting that this one works, but the other one fails. So maybe a good idea is to understand how does this creates the event listers for the mouse. Because this is working fine. Oh, interesting that now it's kind of weird as well. Huh. So now I can move the... Interesting. I think before I couldn't do that. So this is probably coming from this as well. Drag and pinch. Let's see. So it's just the wheel event that is messing up the state. Yeah, now I can't drag, so I still move the balls, but I can drag. Huh, very interesting. So I think this gives me some clues, I think. Now I can drag. So it must be because of the way that because when you're zooming, you're changing the renderer from the thing. But if you're just moving around, you're not changing the state of the renderer. So I guess that's the problem. That's the reason why the other events work as well. And now there's another problem, which is that I'm not able to move the nodes anymore. It's just moving the scene now and not the nodes. And moving the scene changes the nodes as well. Interesting. So I think what I need to clarify, maybe it doesn't have anything to do with the rendering, the React renderer, the custom render. It has to do, yeah, but it must be related, I think, because the canvas is related, the state of the canvas is related to the state of the website. But I think the problem is, and what I should investigate is how is the rendering managing state. I think that's the thing. So I think it's both understanding the stage, because now I think it's not because of the custom component that the problem exists. I think it's because of the stage. Because if it was the custom component, then the dragging wouldn't work either. And it's interesting as well that now, like if I enable the drag, then I can't move the nodes anymore. So the mouse constraints mess up. And they are encapsulated by the app, I think. The world. Yeah, let me think about. I'm going to solve this. I think I need to understand how this one works and how it changes the state of the app. Then I need to understand how the zoom works. Like how it's gonna affect the state. It's gonna be very difficult. I think I need to think more about what would be the good approach, so I don't spend a bunch of time looking at random stuff. But it's very hard to think about what is a good approach because there's so many things involved. I think the main things are the renderer, the app renderer, and like how the event listeners interact with the renderer. There's the connection of the elements of the canvas and the state of the screen. So how are the elements related to the view of the canvas? I think that's the main thing. So why? Yeah, that's the main fundamental thing, I think, is understanding the relationship between the canvas rendering and the state of the application. I think that's the core of the issue. How does changing the state of the canvas triggers the state of the application and how it changes the state of the application? That's the main question, I think. Because that's what's fucking up there. So the question is, what is the best way to understand this, to explore, so I can fix this? There's a lot of different problems as well now. Because even if after I fix the zoom, I'm gonna have to see, like, to think about what is the best approach. Should I keep the mouse component there, or should I remove the mouse and then just leave all the events to the Pixi-viewport? And if I don't do that, then how do I allow for the mouse events? I think it's better to leave the manipulation of the elements with Matter.js, because Matter.js handles the calculations of everything. But I'm not sure if that's possible. Now the question is why adding one removes the other. Maybe it's probably because it's the same event, but should be done on different elements, so you shouldn't cancel each other. And this also works with the wheel. You can move with the wheel. If I zoom, it fucks up. Right, this is much better than the other file. I think I'm gonna finish or see if there's anything else here, and then I'm gonna put some music and study this. I think that the other videos are probably a waste of time to search now. Just gonna study the source code there. I have to understand how the mouse constraint is created, the event is created from the mouse constraint, or from the mouse to manipulate, and then understand why putting the viewport event disables the mouse one. That's the thing. And then I have to see what is the relationship between the app renderer and the events. So I think I have to understand how does the event changes, is supposed to change or changes the canvas. That's the first thing. Once I understand that, I think it's gonna be easier. So I'm just gonna follow the execution. So I think this is the issue here, is that they both use the same event listeners and they are adding the same event listeners on the same object, which is the canvas. Because I'm passing the engine here to create, but I'm not really sure. Because the engine is a different object than the canvas, so like you should be adding the event listeners to the engine and not to the canvas. It's kind of weird. I have to see how the engine is created. I think pretty easy to understand here, just create functions and then adds the event listeners at the end. So here's saying HTML elements. But when I'm triggering there is... Oh yeah, I am passing the app.view. So that's why. So it is what I was thinking about. I confused the two things here, that's why. So here I'm passing the view, and there on the Pixi-viewports it's probably the same canvas. So because it's the outer component, it's gets, but it shouldn't be the other way around, because the outer components, I guess it depends on the order of execution. Maybe what I should try to do is comment this out to see if it's gonna change anything, because it might be a conflict of these two things here, since they are attached to the same element, the event listeners. And the thing is that this one is on the view, and this one is on the renderer. I think it has something to do. So like this brings more questions, but it's like, which one should I choose then? From the elements perspective, it makes a lot more sense to use the mouse constraints. But then I can't just use the mouse because it doesn't have anything related to the view, just zooming and everything else. But then using only this, it might be a pain in the ass to put the events on the elements. That's the thing. I guess what I could do is just copy this class here and then I do my own, because then I wouldn't have to redo the whole library or download the whole library locally and change everything. I would only have to create one custom component, and this one seems very simple. Like I can just copy paste this file, I think, and then I just keep whatever is useful or add. But it's interesting that it's receiving the canvas, but the events are on the nodes. So I have to understand how that works. How is it possible that... Oh no, this is the function. So it just creates everything. Then it calls this function, passing the mouse, which is the object that has all the functions, and the mouse element. I don't understand why I do it like this though. seems kind of weird. Because you're passing the mouse element here. It's just going to become the element and then you're making this equal to this one. But it's probably because of some other reason, like if you're gonna do something outside of the library, then maybe you can set the element in some use case or whatever, and then this would be useful. That's probably what's going on. So mouse element is the canvas, I think, because the element is the canvas in this context that I'm doing here. So it's gonna add all these event listeners to the canvas, which are all the functions that has up there on the other class. So these are the event listeners. And then the other one is gonna do the same probably. On drag. I think the file closed. Oh, here. This is more difficult to understand because it uses these plugins. There's the other class. Plugin manager. I hate when it does that. Oh, I think it opens. Yeah, okay. Hate when it closes the tab when I want to open a new one. So I want to see what event listers are being triggered through the Pixi-viewport to see if it's the same, like if they're overlapping, because that's the only thing that makes the only logical explanation in my mind, and that's one fucks up the other one. So if that's the case, I think that it might be relatively easy to solve. I think that the first approach would be to change the event listeners on this one, because then I don't have to download matter.js, the file locally there, creates the custom components. But also, it doesn't seem that complicated, that's the thing. So, it might be better to... Or what I can do, obviously, is just, instead of passing the canvas, I just pass the elements. But then, like, it will be hard, because then how I'm gonna do that, because I'm not gonna have the graphs of the elements. That's the problem. No, actually what I can do is, instead of creating the component, then what I would do is just call these functions here inside of the particles and the edges. And then I create the event listener. But then, like, it seems that like it's not the correct approach, because I'm probably doing a bunch of computation that doesn't matter. Because if this works, if you pass the canvas, then like it becomes like I'm gonna have to do each one of these for each node. So there must be a better way, I think, that allows me to just use the canvas, and then I find a way to make it so that they don't overlap. Or I change the event listeners on Pixi-viewport as well to also to allow for the thing to move the elements as well. And then I just remove this mouse component. The problem is that they are connected. Like the elements are the tricky parts. Because the zooming and dragging can be like you can change the view, but then for changing the elements, I think you need to. But wouldn't both of them need to change the positions of the elements? But maybe for doing the calculation of the movement of the bodies is different. Because it's not only the position, then you have to trigger the physics engine as well. Oh, this is drag yes. Fuck, how can I ignore all of this annoying errors? It's calling the add function here. So drag, which is the name, and then a class. New drag. So the class is the plugin. Yeah, so I'll have to understand more how this works, but I think it's better to see this class first. So what I want to know is how is it creating the event listeners for this one. Parent viewport. Which is this, and then options. Which are the options for the viewport. Move mouse buttons. You should just search for event listeners. Window event handler. So the ones that maybe I will just copy and paste the ones that the other library has, and then I'll see, where was it? I think that, yeah, that's the annoying thing about VS Code, that it closes this stuff when I open a new file, so I'm gonna have to open that again. The source, or maybe I closed and I forgot. But sometimes VS Code does that. It's very annoying. So copy this event listeners here. And then I'll see if the other file has it. I think I'll be right back. Yeah, VS Codes closed the thing. Fucking lie. So let me open again. So the thing is, they're using different event systems, but I think they're using the same event. That's the thing.
atmosphere, the thought unlocked. Strongest taste, loudest drop, head is filled, the thought unlocked. Strongest taste, loudest drop, head is filled, the thought unlocked. Strongest taste, loudest drop, head is filled, the thought unlocked. Strongest taste, loudest drop, head is filled, the thought unlocked. Strongest taste, loudest drop, head is filled, the thought unlocked. Strongest taste, loudest drop, head is filled, the thought. Strongest taste, loudest drop, head is filled, the thought unlocked. Strongest taste, loudest drop, head is filled, the thought unlocked.
I'm struggling to understand where, like, I'm trying to find where the add event listeners are, but I'm struggling to understand where, like, how does it add events if it's not using add event listener? So it must be on this federator pointer events or federator events, but that also doesn't use add event listener. So I think it's using something else, like it's similar to the emitter from Vue.js, I think, but I don't understand how those libraries work, and it seems like it's not importing any of these libraries there, so I don't understand really well. How is this possible? Yeah, here is the only place. I think the other events don't have anything here. Which is really weird. So I guess what I should try first is to see if I comment one of them out, the component is gonna change or it's gonna make it work. The zoom event. Fucking thing. It still fucks that up. So it's not because they are, which I think is a good thing. But the thing is, it still fucks up the other event. Like I can't touch the nodes now. I guess I have to understand how the drag works. I'm just gonna follow the path of execution there for the drag event. Just calling the drag function is gonna create the class, and that class is gonna create the event, so I have to understand how that works. The other one uses the event listeners there, which is mouse down, mouse up, and mouse move, I think, to create the dragging. So I have to understand how the Pixi-viewport does it. It's drag and pinch. So I think I'm gonna start from this one, and then I'll follow. I'm focusing more now on accuracy because I suck at accuracy. I think I spent too much time trying to get faster, and I didn't care about accuracy too much. think I trained like the wrong patterns for several words, and then this is capping me from going faster. I would like to get to at least one time to 200 words per minute, but it seems impossible. It's crazy how people can do it a lot faster than that. Don't understand how. That's how fast you can think, and also your fingers is related, so it's probably genetics. The people that can type really fast, but I think that at least 200 words per minute should be possible for anyone, I think, with enough practice, but maybe not. And obviously this is not useful at all, just really fun to do it. I think like after, obviously, up until 100 words per minute, then it's really useful, but after that it's just for fun. I think I can do like at least 120 really comfortable. Like I don't have to like force myself at all or try at all. But then like I think I'm usually averaging from 120 to 140. But then anything beyond that gets extremely difficult to do it. Like I think if I really try, I can get 150 consistently. Like really trying to pay attention, but it's very hard. Then anything after that's pretty much luck based on the words and the accuracy that I can get. Yeah, this is the stuff that is weird here. Maybe it's because I didn't install something that I needed from the library, because I pretty much got these files. It could be that, the error that I'm getting. I think it was the master. But if it was that, then it should give me an error thing. Like, should be able to run. I think maybe the event listers are inside of these plugins, but pretty sure I saw these ones, like 2 of them, and they don't have the add event listener thing. Yeah, the rest of the stuff is not related, I think. Sure. Oh, it's using event emitter. How is it possible that it uses event emitter if it doesn't have? It's not coming from the other function as well, from the other class. And that's how. So the container does inherit the event emitter. Through this class here. Yeah, I need to understand more how this thing works here. I think I get the superficial level. You can just subscribe events, put on, off, and then trigger, something like that. So it allows you to add custom events, but I need to understand how this is related to the stuff that is going on the other library. To understand why, when I have both of them on, the one from viewports overrides the one from Matter.js. That's the main thing that I'm trying to figure out now. Because I think that figuring that out is gonna give me clues on why the wheel is not working. And also I need to understand how this works, because later on I'm gonna have to add events to elements anyway. Or change the events that I have already. Or maybe make so that I can navigate through the nodes with the keyboard. Fuck. Yeah, finally. And this keyboard also has some keys that kind of get stuck every now and then. But I think it wouldn't allow me to type much faster. It would just allow me to have more consistency, I think, changing keyboards. I think that's the thing here. So the wheel event is handled by this events object, but the other ones are handled by the event emitter. So this might be the reason why the other ones work, but then the wheel event doesn't work. It's the only one that is being triggered by the events from the app. So is the classes. That's the thing. Is the classes here are responsible for creating the events. So the wheel is created here and the other ones are created through the... But there's also the class there. So maybe it should create the wheel event when it creates this class, because this class is created through here. So and it's gonna call these functions when it receives these events here, which are probably the ones that control what happens when you have the dragging thing, because it's mouse down, mouse move. And I think that the reason why they gave the different names so that it doesn't have conflict with the other ones. But it's still like, that's the thing, is fucking up the other one, so I don't understand why. Yeah, let me see if I comment both of them out, if it's still gonna have the events on the nodes. How is this possible? Oh, I'm looking at the wrong thing. Oh, maybe not. Oh yeah, I'm looking at the wrong thing. Ah, so this still ends the thing. So it's not being done by that class. Let me see if I comment it out. What is it doing by the class anyway? Because there's nothing here that does that, so. Let me look at the drag first. Actually, let me see which one. Yeah, it has to be drag. It doesn't make any sense. It should be the other ones. There has to be this one that allows to move the graph. Plugin manager. So maybe you're just putting that class in this object here. What is triggering the event? That's the thing. Sense plugin, which is this one. So plugin is an abstract class, I think. Just adds everything to the plugins, but I don't understand how it triggers the events. Doesn't make any sense. I guess it's because of the logic for the component outside of this. The Pixi components. So like these functions here, after it's creating, it's just adding the classes to the plugins, to the plugin manager. But they don't initialize the events. At least it doesn't look like they do. I guess when it's doing this, it's just getting the class and then calling the method on class. The thing is, like, on the constructor there, it just initializes the classes, and then if I call the function, it's just gonna add the classes to the plugins. So I don't understand why doing that adds the event listeners automatically. Because there should be at some point the add event listener. But I guess it's just because it is on one of the classes that is inheriting from this, like the event emitter thing. The only one that it gets called is this one. And obviously this one extends this one, so it might be coming from this. Yeah, this one actually adds the listeners, that's why. It's very confusing. Yeah, this is the one that adds the listeners. So let me think about it. Put manager. So it is calling. Let me see if I comment this stuff out. What is gonna happen? Because how is it triggering the other ones? I guess it's the same thing. Like, because it signs up these classes, then inside of the other ones it's gonna trigger something. Like inside of this class. That might be the plugin one. It's so confusing to understand. Like, I have to figure out where are these events going to be triggered. That's the thing that I think. But it's probably because of the container class that the viewport inherits. And the event system from the viewport. Maybe that's why, like, so let me think about it. Because it initializes this, then it adds these events, and then once I call the functions here, these functions is gonna add the class of each one, which is these files here. So it's like, when you call this, is adding the plugin to the plugin manager, I think. Yeah, this plugins, which is the plugin manager, and then it's gonna call the add function. Which is gonna put everything inside of the object of this class, which is the plugin manager. And then we have these get functions here. And then it's just gonna return this. So it creates the name of the event with the value as being the class, which is the file there. You just see which one is initialized first. So first is the input manager, then the plugin manager. So it signs up all of these events, and then it creates this. But this just creates the plugins, and then you call, and then you add the stuff to the plugins. But then after that, nothing happens. Like, so let me think about it. Like maybe inside of this class, but then here, like, there isn't anything besides this, which is for like the keyboard. There isn't anything that says that when this, like, when that triggers the event, that should trigger these functions here. So I don't understand how, like, why calling these functions is gonna add the event, because that's the thing that I'm struggling. And if I do this, it should add the wheel event here. Let's see if that happens. Oh, actually, it's better to just comment, but I think it's not gonna work. Also, it does work. And it's interesting now that it works, but it seems that it's faster to break there. It's breaking right away. But if I put this stuff here, I think it takes a while to break. So I think there is a difference. Yeah, here it zooms a little bit and then breaks. Interesting. So I assume that this is the stuff that is fucking up, but like, I still don't understand how is it possible that what parts of the whole thing are the events being triggered. Like, yeah, because it's signing up to the events here, I think, but then how does adding the classes is gonna make it so that it triggers the events? That's the thing that doesn't make sense to me. Let's see, pointer move. Let's put just pointer. It probably comes from these classes here, I think. That's probably the thing that I'm missing, because this class inherits and the other one also inherits from other classes. But like, it should be actively calling the functions, if that was the case, if it was triggering any of these functions here. Overrides. Like, when it's creating the class, it's just gonna create the constructor. So that's the thing that is weird. Yeah, that's where, yeah, here. So I think I changed Let's see if it works now. Yeah, now it's not working. So it doesn't do anything. It shouldn't do anything. And this does. Weird. So like the functions here shouldn't do anything. Because they're just adding the classes to the plugin manager. But how is it possible that I can drag if it is not signing up any event listener to the dragging? That's the thing that is weird. Like, it must be because... Yeah, but it can't be because these are like standard events. I need to understand how the event meter works. I need to study this library. Because it doesn't make sense to me. Like, and if I comment everything here, then oops, then I think it's not gonna work. That's the thing. I still zooms because of the other one, but yeah, now I can drag the view. So it must be because of like this. No, it must be because of these functions here. You shouldn't have anything to do with this. Let me see if I do this here. I can't drag anymore, so this is the function that is adding, and the other ones don't have anything to do. Oh, but it's weird because yeah, I think that's correct. So the dragging comes from these parts here. So at some place it should be emitting these things, but it doesn't emit from here. Yeah, if I just... Yeah, but if I comment this out, I think it doesn't work as well. Yeah, it doesn't work. So it's both this thing, and then adding the things must be adding some events. Yeah, now it allows me to drag, so... But it doesn't make any sense to me. Let's see. Drag. Like, what am I missing here? The plugins is just the plugin manager, and then it's calling the function, which is just adding to the object this class here, which is the file there. Yeah, plugin manager, so it's calling this function, This function is the object here, so it's receiving the name, which is drag, making it equal to the plugin, which is the file, this other class here. This is adding that to the plugin manager. But then how does adding that to the plugin manager make it so that it has the event, it triggers the event? This is what I don't understand. Because plugin doesn't have anything to do, like it doesn't trigger anything. What the fuck is going on? Must be because of this imports, the federated events. Let me comment this out, see what happens. Yeah, it still works, so it's not this. I think I can just comment this out as well, just see what happens. So I'm not overriding. Let me see. Or maybe it's because of this override then. Maybe it calls the function. Yeah, that's what I think. I thought. Like it's just overriding the function, but it doesn't call. It wouldn't make sense to call. Yeah, but it shouldn't change anything, I think. To remove this. It must be something else, I think. So let's comment this one out. How is this possible? I guess it is calling one of those functions. The thing is, I don't remember what I'm passing as options there. So I don't know if it's calling these functions or not. Like this one. But this should only be related to the keys and not the mouse. A keyboard event, so shouldn't have anything to do with the dragging. So, like, it is calling this after it's initializing. So let me think. Like, how can that be the case? It's clearly it doesn't work because it's supposed to initialize here. Input manager. Yeah, I guess it's just because of the event emitter thing that I don't understand really well how it works. Like somewhere along the hierarchy of classes that is triggering the event. Or is this here? Like this sets up the event listener. And then it calls this function. So maybe it's as simple as that. But then why does this one work and the wheel doesn't work? I guess it's just because the wheel uses the normal events. Like it's adding the events to the DOM element, and the other one is adding to the viewports. This might be the reason why. But I don't understand why they did it like this though. Why make it so that some of the events are on the viewport and the other... I guess it has to do with the way that the canvas, the render relates to the view. I think. Both of them have to move all of the elements though of the canvas. So there's something weird. Let me think. So let me uncomment this before I forget. But I think I understand now. Because the confusing thing to me is that in my mind something, I don't remember really well how it works. That's the problem. But I think like something I should set up the event listener, and then something else I should trigger the event listener, I think. But maybe I'm wrong. Maybe like all we have to do is just put this on here, and this is coming from the event emitter tree. And then once you do that, but then how is it gonna know? I guess it's just a standard event, let's say. That's the thing, because it's the same way that this event listener works, like just a standard event from add event listener. So you don't need anywhere else in the code to trigger this event. Like this is done under the hood from probably like some, I don't understand below, but it's probably somewhere. Like it's the whole explanation, the whole talk that the guy was explaining. It's something under the hood from JavaScript that's gonna trigger an event loop, and it's gonna do the whole cycle thing of creating micro tasks or queuing tasks. So it's something under the hood. And you don't need to trigger anywhere else on the code. I think that's what's messing me up here. So I think if I comment that out, it's gonna fuck up here. Yeah, it doesn't work anymore. And these ones. So the question is, why does these ones fuck up the other ones? And I think like there's obviously a conflict, but then how is it possible if the events are different? That's the question. Like they are both attached to the canvas, but like now I can't move the nodes. But because they have different names, it should be different. But maybe, yeah, I guess I have to understand more how the Matter.js one works. Because how is it possible that you attach the events to the canvas and then it works to move the elements inside of the canvas, the nodes? So I think I have to understand more how the Matter.js one works. Yeah, but here also, I think I was gonna try. Like, what if I just put this on the viewport? If it's gonna work. Yeah, now it goes up and down. Interesting. Yeah, because it's not the canvas. Or maybe it is the canvas. I forgot where I'm console logging this. But why calling, that still doesn't answer the question. Why calling the function makes it so that it works. Because if it is setting up the events there, then how does it change here? By initializing this class. I guess it's because the way that it sets up here has to do with the plugins. I think I'm console logging here, maybe. Yeah, here. Yeah, let me think about it. Now what if I think I'm gonna try this one. There's so much stuff to like think about. It's very confusing. The viewport is the class. So it's triggering the event in the class. And then the other way would be triggering in the canvas. So when they call the event listener on the viewports, what is the thing that is being triggered? Like it should be the canvas as well. Yeah, I guess I have to follow the chain of connections there. Sure. Yep, it doesn't make sense because I was adding directly to the viewport. I guess the viewport would be the component, the custom component. The class here, in this case. Because it's creating based on the prompts. Here, and then it returns this on the creation, which becomes this thing here, I think. So it would be this element here, I think. That's why it's scrolling up and down. So the child of this element would be the... No, the parent of this element would be the canvas. That's why he's doing the other way there. And it still does the same thing here. So I guess that's the main difference. Is that these events are being triggered on the custom component. And the other one is being triggered on the canvas. And then that's the wheel. That's the reason why the wheel is not working, the other ones are. But if these ones are being triggered on the component, then why does it disable the mouse events? I think I have to focus on either one solve first, otherwise I'm gonna be confused, I think. But to solve to understand the reason why these ones disable the events on the nodes, I have to study more the Matter.js one, the mouse, to understand how these ones work. Because it's obviously because there's a conflict, but I don't understand. Because they should be on different elements. But maybe the Pixi... The viewport's not this element, is the... Like it's the same one that is the app.view. What would be the app.view component? App.view is the canvas. So I guess that's why, is because like I'm adding the events on the parent component. No, actually it's the child, because the canvas wraps the custom component. But maybe that's why, like, because I'm wrapping the other events in the child of the canvas, it messes up. Like it overrides the canvas ones. So which whichever layer is deeper, let's say, it's gonna override the outer layers. I think there's something about this as well in the documentation of one of the libraries talking about bubbling, which is this effect of event listeners of one hierarchy, one part of the hierarchy of the tree, bubble down to the other elements that are childs. And I remember that there's something about it, I think it's on Matter.js maybe, that says that it doesn't bubble. So maybe it's something like that is going on here. Because these ones are inside, they gain more importance in the hierarchy. And then it overrides the other ones. Yeah, the viewport should be the main container in the canvas. No, not in the canvas, on the inside of the canvas. Because it is inside of the... Oh, actually it's outside. Because I'm wrapping this, that's why. So I think that, yeah, now it makes more sense. I was confusing which one is on higher. Like the world is wrapping the mouse and the Pixi is on inside of the world here. So that's why. So that makes more sense to me, I think. So the world is here, the mouse is inside. So because the Pixi is outside, it's like it's more important, let's say, than the mouse. And that's why when I have the effects there, when I bind the events to the Pixi component, it removes the events from the mouse, because it's like it's on the outer layer. Maybe like I could test that by changing where I put the components, but not sure if it's worth to do that now. So the question is why calling this thing here triggers the events. Because if I comment that out, then it removes the events. So yeah, it doesn't work. And if I call, then it starts working. So I think that it is correct that the input manager just subscribes to the events. So that when you do this stuff here, it just subscribes. And then it should be triggering at some point. The drag to make it happen. Yeah, because now it doesn't work still. But then if I comment this out, it's gonna work. Yeah, now it changes the screen. So how does calling the function? It doesn't make sense. Yeah, it's just adding to the plugin manager the class. So maybe Yeah, let me see here. But this should only be triggered after you call the function. So it doesn't make sense that it would be because of this. So it's adding, which is gonna be this plugin. What makes it so that that thing triggers? That's the thing. Maybe it's because of something that I don't understand from the custom component here. Like what happens when it returns this thing here? That's what I need to know. Because it can't be anything here. That wouldn't make sense. Because there's nothing here on the constructor that should trigger the plugins. And it's not on the plugins class as well. Oh, maybe it's because when you don't call, then even though it's triggering, I think I know what to do. Just see. So I should just console log inside one of these functions, and then I think that's a great idea. And then I just comment out this part. Because then I'm gonna know. Yeah. So it is triggering, but it's not calling. So that's why. So it only works after you call this, because then you have the class inside of the functions that are triggered here. Yeah, this part. So is it the logic inside here? So I guess these are just standard events. So I think I understand now much better. But now I have to, because I still like, yeah, now I understand how And I think I know why the dragging. Maybe I will just change the order there, just see what happens. So I'm just gonna remove this from here. And I'll add like below the world, just see which one is gonna work. Because I wanna test to see if it is, like, make sure it is what I think it is. That is making the thing not work. Oh, that's the problem. Not sure if it's gonna work here. Because I'm declaring the stage here, so. Yes. It's better to just put inside of the component. Let's see the mouse. Yeah, but that's the problem. Because if I wrap here, then it's the same issue, I think. But maybe I can try, because it's the easiest thing to do. Basically, I want to put the custom components on a level lower than the mouse. Just see which event's gonna be triggered. Is it gonna be this one or the other one? Fuck. Yeah, it's annoying because I don't have to change everything. Like, I guess, yeah, I'm done. Should just change the other order of the world and mouse. But then it's not gonna work because of the engine. Yeah, I guess I can test. If it is too complicated, then I'm just not gonna do it. I'm gonna try to fix the other stuff first. The mouse first, the wheel first. Yeah, that's the thing. Fuck. Yeah, so it's too annoying to test, but I'm pretty sure that's what's happening. Because this one is one level higher, than it takes precedence over the other one, over the other events. So because yeah, but obviously I don't understand really well, because like this one is using the event emitter tree, so I have to study more, because I don't understand, like, if the name is different, how is it possible? But I guess like it's because both of functions are conflicting, so like they're both doing calculations with the mouse position and like changing the screen based on that, changing the canvas. So like it makes sense that one of them has to work and the other one doesn't. Like I think that the event is still working on the other one, but because the element that you're clicking is the canvas, like that takes a higher priority, let's say. So it's like you're masking the element inside with another event, but then if that event doesn't exist, then it accesses the actual element inside of the canvas. I think that's the only explanation that makes sense. Oh, I know another thing that I can try. It's just easier if I put this on another. Yeah, but this is a problem as well, because if it is the reason that I just talked about, then it's not gonna matter if I put the element here, because it's just gonna. Also, don't even know how to do that, because the elements are gonna be defined later, so it doesn't work. Yeah, this sucks actually. How is it changing the actual particle though? I guess it's just calculating the position of the mouse. Maybe. I don't understand how this works. Like the issue here is that, like, if I'm gonna use the renderer, and if it is the thing that I'm thinking about, maybe I should just draw this on Skyly Draw. It's a massive problem, because I think like what is happening, and maybe I should do, oh, actually change later. Like here outside is the Pixi components. But the thing is that the mouse should be created, so it is the other way around, because the mouse is on the canvas, is on that view. So maybe, so Pixi components is here, and then the canvas is here. But then why does the Pixi? It doesn't make sense. So what I think is happening is that it's overlapping, because they're both like on the same thing. Like, so when this is on, when you click, the event that works is this one, because it's is on top of the canvas. So even though the event on the canvas still exists from the mouse constraint there to move the elements, the event that gets triggered is the one that is on Pixi, because Pixi is on top of the canvas, let's say, which is the event of the viewport. But the issue here is that, like, I can't think about an easy way to attach the event of the mouse to the elements themselves, because the elements are going to be created after the mouse is created. So I can't pass the references because they're not going to exist. And if I guess what I can do is create a ref and then pass to see if it works. Like pass inside of pass the reference of the Pixi component to the mouse, and then attach the event to the Pixi component instead of attaching to the canvas. Instead of attaching to the app.view, I would like get from here, from the props. It gets complicated as well. Because then how I'm gonna do that? I guess I can do it from the main components. I think I can test that, but even that it may not work. The problem is that if it doesn't work, then how I'm gonna put events on the elements? That's the question. If I'm using Pixi-viewport, how I'm gonna put the events on the elements if Pixi-viewport is gonna override the other events? That's the problem. Not sure if this is gonna work. I put any name here just for now. Just to test to see if it works. And it's annoying as well because then I have to put another condition here. Like to see. And then everything else. I don't think I'll use this, but oh, actually I should be here. But I want to see if it's gonna work. If I do it like this. I think before I even try to fix this, I'm gonna try to fix the wheel. because this yeah, but it is a very big problem as well, because it's a lot worse if you can't move the mouse. It doesn't work here, but it's still undefined. That's the problem. Yes, it doesn't work. So two big problems. One is the wheel and the other one is fixing this stuff. Yeah, I think it still works, but it's just masked over the... I think this... I would like to test this though, just make sure that my thinking is correct, because then that's gonna change the way that I'll try to solve this. That's the problem. Like, how I'm gonna think about how to structure this thing so that the event listeners work. Damn, it's almost 5 hours that I've been here. I'm gonna stop now. I'll continue to think about this tomorrow. Maybe I think I'll probably focus on the wheel first. It might be an easier thing to solve, and then I'll worry about the elements. Because to understand how to put event listeners on the elements. Like, one solution would be to just put event listeners from using Pixi-viewport, or just manually adding event listeners instead of using the library. I think that would probably be the easiest one, instead of using the matter.js. And then I can just copy as much functions they have there to do the calculations in the correct way. And then I would just add the event listener to the elements themselves. Or I can create the mouse constraint inside of each element as well, instead of creating like on the main component. So I think it's not that big of a problem. The wheel is harder to solve, because I don't know like which direction to go. I don't understand why this is not working. It's on the problem with the render, the events on the render. So I guess I have to see on the input manager. This one, it doesn't matter. I think adding maybe I should remove this to see if it's gonna remove the zoom. It does change the zoom, but it's still fucking up, so I guess it changes the thing that is attached to. Yeah, this one also doesn't change anything here, so it must be something in the input manager that changes. Options. When you add the wheel class to the plugins. It also doesn't make sense, because there's oh, here, so it does make sense. It's the emit that triggers the events that I was thinking about. And the on sets them up. Yeah, so the wheel makes it so that you go there. But I think maybe it's not necessary to have the function. But it's interesting when I remove this thing. I guess I'm looking at the wrong class as well. Clamp zoom. Yeah, but it still works. It just doesn't zoom. So the one that makes it zoom is this one. But I still don't understand how this works. It doesn't make sense to me. It has to be through these functions here. That's how. It's from the display objects. The thing is that this should be called regardless. That's the problem. So the thing that has to change is this thing, I guess. Like that's the only difference if I don't call the function. Because the only thing that the function is doing is adding the wheel class to the plugin. It's adding this class to the plugin. What does this emit? So emits here. Zoom. Yeah, but it shouldn't emit any of these events. And this one's only working on the... So I guess what I can do is just do this. It's gonna break probably. It's already breaking, but so I guess the only thing that it does but this somehow allows it to zoom. So when I call the function, the only thing that it does is just makes it this return true, I think. Let's call these functions with the event. Oh, that's the thing. So inside of this function, it applies the calculations to change. Yeah, it's just because like it doesn't happen here, it doesn't mean that's not gonna happen inside of here when it's calling this, so I think it makes sense. Yeah, but the only thing it does is just adds this thing, and then inside of this function is gonna, that's where the zoom is gonna happen. And I don't know why, like why is emitting this stuff here. Yeah, I already looked into this. I guess like when it meets on the parent, maybe it receives here. Oh, there's nothing here. Maybe it's not used and it's just emitting for the sake of emitting. In case you want to build something that listens to it, but it's kind of weird. But on the VGS, that happened as well, where there are some events that are emitted, and then there's nothing listening to them, I think. Yeah, so I guess that makes sense. So we need both, because they call the function. And if you don't, then it's just gonna add the event listener, but it doesn't give you the zoom effect, because it's not calling this function here. Yeah, position points. Yeah, so the question is why the events. Why this is no. It has to do with the rendering cycle, probably. It's the only explanation that makes sense to me right now. What if I put dome element here? And position to points. And this function doesn't exist here either. Maybe it's because the function is incorrect. It should be an event system. Event system. I guess it doesn't exist here because the event system is inheriting from somewhere else. And this is the part that I've seen already. Oh, let me think if that makes sense. It could be because I'm passing the wrong thing there, but pretty sure that's the correct way to pass. I think I'm gonna stop here. I wanna keep looking because I wanna fix this thing, but like there's nothing I can do except keep trying. Like I don't. The issue is that there's so many different things that can be wrong, but I think I'm making progress because now I understand much better how everything works. And I think the other stuff, I'm on the right track. The reasoning for the other stuff. So I think I understand now how it works. But the problem here is that I'm not 100% sure. I don't think that I'm passing the wrong thing here. Otherwise, it wouldn't be console logging anything. I think it has something to do with the way that the rendering works. Because it's not being able to access parent element, but also when I console log there, it doesn't show anything as well. So it could be something else. Like when I console log inside of this function, from what I remember, it doesn't show anything. But maybe it doesn't show anything because it's just part of the node modules. I think that's why. So the version that runs there is different than the version that I have here. So like by changing the source code here, it's not gonna console log anything there. I think that's what's happening. And that's probably the reason why the error that I get, the error messages on this one, but it's actually coming from inside of this function. On this file, the event system here, on this. I think that this is the file, so this is undefined. No, maybe this is the, yeah, this is probably the file that adds the event listeners. So maybe it comes from the application. But why it doesn't show here the function? Doesn't make sense. I'm gonna stop. Probably gonna continue this off stream, but tomorrow I'll keep doing this until I solve the shit. So